Welcome everyone to day 2 of the completely free AWS Certified Solution Architect Associate 2022 course. This is a free full AWS certification course, and we want to do everything we can to help you have the best experience in the AWS Certified Solution Architect Associate 2022 course that we're running. Let you know all of some of the things that we've done so far. If you missed us yesterday, don't worry, you can catch up on yesterday's video on our channel. We're going to keep the videos here. So if you missed it yesterday, don't worry. You can access day 1 of the AWS Certified Solution Architect Associate course on our YouTube channel. So go out there and watch it if you missed the first day. And if you've been learning a lot and having a great time and you want your friends to attend too, guess what? Give them access to the YouTube channel. It's completely free. So I want you all to have an amazing, amazing experience. Welcome, Abigail with the Blue Wrench. Welcome, Chow over there, thanking me, help with the Blue Wrench. Thank you so much. We're going to get started in approximately 2 minutes. I want to go over a couple of things because we basically we're teaching this course from an architecture perspective, not a cloud admin perspective. And many of you still want to learn how to do it from an admin or an engineering perspective. We have a completely free companion lab course that you can do. Go download it. The link is in the description as well as the chat box. So go down there and get it. Go get the labs. Go do the labs on your own time. We want all of you to get the skills. So you got it all. It's completely free. Please also, while you're at it, download the companion ebook. We have a book that covers both the AWS Certified Solution Architect Associate and professional exams. We'll pop the link for it as well. The link should be in the description. Get the companion book. Watch the video. Do some of the labs in the book. Read the book. Get yourselves trained and get yourselves capable of becoming an expert in your field. Take control of your own destiny. Now, tomorrow on Thursday, we're going to have a completely free How to Get Your First Cloud Architect Job webinar. And we will teach you everything that you need to go from certified to hired or brand new to hired. We get people cloud hired every single day of the week, and we can help you get cloud hired too. And tomorrow, completely free, we'll tell you everything you need to do to get that first cloud architect job or solution architect job. So please join us completely free. And before we get up, one last thing. Our team doesn't run sales that often, and we are celebrating 1 year of success. So far, 4 of my students got hired this week, and several of them were big jobs too, and I'm beyond excited. Plus 1 person from YouTube that sent me a message that got hired from following our videos. So we are celebrating with a 30% discount off of all of our programs until April 15th. So if you want to get cloud hired, now's your chance to do it. Huge sale. It's literally less than 1 day's pay for the average cloud architect for us to get the average cloud architect hired. And it's a great career and we love it. So if we can do this, now we're going to start and we're going to get over the concept. But you know me. You know, I love knowing where you're from. Oh, I see Eddie Patrick. I know he's over there in Cameroon right now. If you can give me a hashtag cloud hired and tell me where you're at, and then we'll begin. I'd like to start a few minutes after the hour because it takes YouTube a few minutes to signal everybody to come here. And I want you all getting hired. I want as many people to take advantage of this free full AWS course as possible. And yes, you can buy a Porsche if you get hired as a solution architect. If that's not really an issue, and I know quite a few solution architects, cloud architects that have. Brian, well, cool, cloud architect, cloud hired in Philadelphia. That's a city I know well. Simon, cloud hired North London, spent lots of time there. Al Money, yeah, cloud hired from San Jose. I've been to both San Jose, California, and Costa Rica. Love the one in Costa Rica. It's beautiful. Charles over there in Dallas. James is there, is in DC. DeLune is in Delaware. I went to school there. James is in Liverpool. Haven't been there for a little while. Jano is in India. Ruth is in Maryland. Ruth is amazing. Danny's in Canada. Wow, we've got Addie in Connecticut, and I haven't been to Coventry, UK in a couple of years, but I always loved it. Mr. Businessman, I know you're in Atlanta. Jim's in Indiana. Clint is in California. I love this. Congo Emmanuel in Abu Dhabi. Haven't been there for a few years. Loved it. KMO's in New Zealand, which I love. Canada, Amsterdam, Virginia, India, Thailand, Arlington, Chicago, Zurich, Switzerland. I haven't been there in a couple of years. The Phoenix Desert for Robert and a few. Asheville, North Carolina, which I love. Leo's over there in Brazil. Latifah's in Rhode Island. And And Mr. Singh or Lion is over there in New Jersey loving this, and East London. So you can see we got a lot of people here. So, if you're willing to kind of help us build our channel and our free offerings, if you're willing to like, comment, and subscribe on our videos and hit the bell, we're very appreciative. That helps the algorithm tell other people that what we're doing is important so others can get help. And we do this completely free because we want to help as many people all over the world that need the help. So we're really excited by that. So please do so. Please share this. Share this free training to help as many people build their best careers as possible. So love that you guys are all over from all over. I think this is terrific. So now we're going to get back to the context. Oh, Mozambique, love it. Cameroon, this is just so wonderful. And get the free guide, get all of it. Somebody said outer space. I'm cool if you're in outer space too. I absolutely love that. Wherever you're from, whether it be Haiti or Texas, is just great. Nairobi, Kenya, wow, that's a place. But every time I go there and I hear Nairobi, I used to hear it in the Dubai airport every week. Spent lots of time in Scotland and South Africa, Claudette. It is just fantastic. So with seeing so many people from all over the world get together to build better careers, this is why we do what we do. So that's what makes us so happy. So everybody, let's get you, do whatever we can to get you one step closer to getting cloud hired. So we're going to begin today talking about block storage. And why are we going to talk about block storage? Quite frankly, block storage is the only kind of storage we can use on the cloud that we can mount into our servers. So anywhere we would normally need a normal hard drive, we're going to use block storage, and here's the reason why. In a normal environment, your server has a hard drive, and your server stores the stuff on the hard drive, which is beautiful, right? It is. It's beautiful, it's magical, and great in so many different ways. And the cloud, we don't have that action. And since we're on the cloud, and really what a cloud is a virtual network in a data center. It's nothing more than a data center and a network that's been tuned and modified to work in a virtual environment. So that's it. So we've got a server. Let's say the server's like my phone. If we don't have access to using the storage inside the server, we need to connect the server to storage somewhere else. And that's what we're talking about block storage. Block storage is a storage area network. So big giant boxes filled with hard drives with high-speed networking, either fiber channel networking or IP networking that's plugged into the servers. So that's how the servers are going to use it. So block storage is used in all cloud providers. Build a Nutanix cloud, block storage. Build an OpenStack cloud, block storage. Go to AWS, block storage. Azure, block storage. Google, block storage. It's always going to be block storage. So we're going to be working with this. And for your certification exam, we're going to call block storage high performance storage. And we have to for your certification exam. Because according to AWS, it's fast stuff. Now, in reality, block storage is not fast. But on the cloud, it's the fastest we've got. So you give a marketing department a term and say, hey, we've got block storage, and they say high performance, ultra fast. Well, I want you to understand this. You can all go right now to Best Buy, and for $150, buy a Samsung 980 Pro. And guess what? It'll perform 15 times faster than an AWS EBS Provision IOPS Volume 1. And we'll talk more about that later, because we're going to talk about speed and latency versus throughput and when it matters. And it's going to be fun stuff, cool tech stuff. But understand that block storage is the fastest we've got on the cloud. But don't go tell your customer it's elastic and fast, because their customers know better. So block storage is what we use because it acts like a virtual hard drive. And the reason is when we write to a hard drive, we typically write our data in blocks in some way, shape, or form. Our files get stored as blocks. And when we're dealing with the cloud, since we don't have access to the hard drive, we use block storage to feel like a hard drive, because the way we store data on it is very similar to a hard drive, even though it's over a network. So keep that in mind. Now, why do you use block storage? Anytime you need a hard drive and a computer on the cloud, your only choice is block storage. So if you've got a database, you can use block storage. You got a web server, it's going to use block storage. Pretty much every virtual machine you're going to use is going to access block storage. Now, block storage is really scalable. And why do we love block storage? What makes it so cool? Well, storage here, server here. That's why we like block storage. So it's not like we have to pack our servers with storage. We can basically pack our servers with CPU and DRAM and GPUs, leave the storage out of there, connect the storage to the storage area network, and we've got almost unlimited scalability. And that's what all modern data centers for the last 15 years or so have used block storage. Now, when we're dealing with virtual machines in AWS, remember, as soon as the instance or virtual machine gets terminated or shut down, all the data that's stored on the local hard drive is lost. So, system termination results in losing your data. Well, I don't know about you, but I've not worked with a customer in my life that said, I don't need any data. So because of that, the data matters. So we're using block storage to persist after system termination. So some cloud providers call it persistent storage, which is an excellent example for this because it's storage that persists after the system is shut down. Now, when we're dealing with AWS, they'll tell you that block storage is used for mission critical use, and that is true in all kinds of databases. And they will tell you that it's high availability, meaning that it's 99.999% available, which is pretty darn good. That means the block storage will be available when you need it most of the time, except for 5 minutes and 15 seconds per year. So this is pretty solid, reliable storage. Now, according to AWS, you use elastic block storage for its high throughput and high transaction workloads. Because remember, it may not be fast, but it's the fastest we've got on the cloud. Now, typically, block storage is associated with a single area availability zone. And here's the reason. We want to get it close to the servers, but it's automatically backed up to another availability zone. So this is pretty rock solid stuff. Now, one of the things that we really do love is the way EBS volumes are backed up. So here's what really goes on. We've got our virtual machine, EC2 instance, whatever you want to call it. I'll call it a virtual machine because that's what it is on every cloud. And when we mount an EBS volume or a block storage volume to our virtual machine over here, what we can do is we can create a snapshot of it. And what is a snapshot? A snapshot is just a picture or an image that's an identical copy of the volume. So, there are people that use, for example, tape backups, and they back up every single file. That's a file backup. But many of you have worked with, say, VMware ESXi, and we've created an image of a virtual machine, and we can move that image everywhere. Well, when we do an EBS backup, what's going on is we're creating a snapshot, which is a mirror image of everything, and we're storing it. Now, with that one snapshot, we can rebuild that volume identically. So that's what we're doing. We're backing up via a snapshot. So let's talk about how do we size, how do we spec out block storage volumes or EBS volumes? Well, there's two metrics that we have to deal with in drives. And the two metrics we're dealing with are realistically latency and throughput. And let's talk about the difference. Latency is how fast you can access the drives. Boom, 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 read, write. So that's, what we're really talking to, latency. So the more times you can read and write to the disk per second, the less latency it says. So if you can read and write to the disk 1 million times per second, it's got low latency. If you can read and write to the disk 2 million times per second, every write is 1/2 millionth of a second. So you can see, as the reads and writes go up, our latency goes down. So now let's talk about this. How do we measure read and write per second to a disk? Well, the people decided to call it input and output operations per second, or IOPS. So when you hear this ridiculous acronym, IOPS, what are they talking to? It really just refers to the number of times you can read and write to the disk per second. So the greater the number, the faster you can access information. So let's talk about IOPS in terms of latency. So now I want you to have two cars. One car is my nice, happy SUV with a 2-liter diesel engine that gets 30 miles a gallon. And next to me is a Ferrari that's performance tuned. So we're both at a stoplight, and the guy in the Ferrari says to me, "Hey, Mike, let's go race our cars." And I say, "I will take my happy, 50-year-old person, responsible minivan against your race car? Sure. So we both hit the pedal. And as soon as we both hit the pedal, here's the thing. That person in that Ferrari already did that quarter of a mile. And I'm sitting there in my beautiful diesel, super comfortable SUV. And 30 seconds later, I get there. So who was faster? The Ferrari. The Ferrari was far, far, far faster. It has less latency. So there's that. Now you know. Now, by comparison, I've got a big SUV and it's big, comfy seats in it. Real comfy. Really good on my 5 herniated discs, my 2 torn rotator cuff, my labral tears in both hips. And when my back hurts, I push the seat warmer. So that's why I bought it, because it's comfortable. Now, we've got another thing in technology called throughput. And throughput is the amount of stuff you can move. The stuff you can move. So that we measure throughput in terms of megabits per second or gigabits per second. So now I want you to think of this. I've got my big SUV, and now we got the Ferrari. And we both have to go to something that is 20 miles away or 30 kilometers away. 30 kilometers away, we have to both go. Now, in this case, the person is not concerned by how fast we get there. We're concerned with how fast we can haul 2,000 pounds there. So now that's referred to as throughput. So now we've got to go 30 kilometers. Now I take my big, slow SUV and I go those 30 kilometers in 15 minutes. Now at the same time, the Ferrari gets there in 11 minutes, but the Ferrari carried 200 pounds and I hauled 2,000 pounds in my cool, relaxed, super soft SUV. So who can haul more? Who has more throughput? Well, my SUV, far more than the Ferrari. Which is faster? The Ferrari. So when it comes down to disk performance and architecture, we have to choose what we need. Do we need to move a lot of stuff? Or do we need to do a lot of small read-writes? And let's think about that. If you're dealing with a database that's recording transactions, and you're getting 1 million transactions a minute, you need 1 million writes per minute. So that means something that needs low latency. Now, by comparison, if we took a video of my beautiful cat Cindy, and one day Chris will put a picture of my cat Cindy likes to chase butterflies and dragonflies, and she does silly things. And, if I use my 6K video camera, which I'm actually using right now, but we're streaming in through a bunch of encoders, and I make this video, I can make a terabyte of video every 13 minutes or so with the frame rate that we record at. So now, if I need to send a large amount of data, I need throughput. So when you're moving lots of stuff, you need throughput. But when you're doing a lot of read-write operations, you need low latency, which means high OPS. So throughput is always measured in megabits per second or gigabits per second. And latency will be measured in IOPS, meaning the higher the IOPS, the lower the latency. There's an inverse correlation there. So keep that in the back of your mind. So let's talk about the kinds of EBS volumes that you can use on the AWS cloud. So the good news is AWS came up with the newer version of block storage, which is almost fast enough. It's relatively good. Now they call this EBS Provision IOPS IO2. So these are brand new. Now this is the highest performance SSD storage you can buy. It's the lowest latency that you can buy on AWS. It's designed for workloads that require relatively high input-output operations per second, so it's really good for a big database or an application requiring low latency. Now, this option gives you good enough, latency with regards to IOPS, and relatively good performance in terms of throughput. So these EBS volume types, the IO2, can do upwards of 4,000 megabit per second and upwards of 250,000 IOPS. So that's pretty darn good. Now that drive that you bought for $150 at Best Buy will get you about 7,000 megabit per second, so almost twice as fast. And it will also get you about 1 million IOPS. So again, that's about 4 times less latency than this. But you got to see, this volume that we're talking about, the EBS Provision IO2, is almost as good as a $100 drive at Best Buy. And honestly, in cloud computing, to get something that's that close is awesome, because look, there's never are going to be anything as well that performs as good as the network and the data center. by going to the cloud, we're renting somebody else's network in the data center, so we're getting a part of what they have. So we can expect it to be slower and perform less on the cloud, and we have less control over it on the cloud. But the cloud is so agile that it's going to be worth it in most cases for us. So the next question, the next block storage volume type that you can use are the EBS provision IO1. And until about a year ago, this was the fastest you could get on the cloud, but this is pathetically and painfully slow. Let's be honest. AWS would call it high performance SSD storage. They'd say it's low latency, and they would tell you that it's for workloads that require high input output operations per second. They'd say use this for a large database or low latency. Here's the thing. This gives you about 1,000 megabit per second throughput, which is relatively good. It's about the speed of a 10 gig interface. But the next part of it is as follows. The latency can only go, the IOPS, or the input output operation per second, can only go up to 64,000. So if you think about that, if we really needed the performance of that drive, that Samsung 980 Pro that we could buy at Best Buy for 150 bucks, we'd have to use 15 of these things to equal the performance that we can get for about $150 in the data center. So I want you all to understand that the local computer store thing is about 15 times better than this, and this is expensive disk storage. So understand this, which means when you're dealing with EBS volumes and you need high performance, you're gonna have to work around it and use RAID. So we'll talk about the RAID options and RAID as well. And I know that's not covered in the Certified Solution Architect Associate, but you'll need to do it in the job, and I want you to have the skills for the job. So keep that in the back of your mind, your EBS provision IO1. They were the fastest until recently, but they no longer are. Now, the next type of block storage we can use is something called EBS general purpose. Now, this is general purpose SSD drives, meaning SSD drives, not non-volatile SSD drives like the PCIe and NVMe drives that we're using for high performance. This is just regular SSD drives. And because they're standard SSD drives, they give you a good balance of price and performance. And these are perfect for a boot volume because, you know, how much latency do you need on that boot volume? So perfect. Now, this gives us what I'd consider moderate throughput, like 250 megabit a second. It's a little faster than a regular hard drive, but half the speed of a real SSD drive. And the good news is it's got, you know, relatively decent IOPS. You know, we're not going to get anything close to what we're dealing with those local hard drive, but it's good for a transactional workload. It's perfect for a dev test environment. So maybe you need to use the provision in IO2 devices for your production environment, but you can get away with this in your test lab. So, or you can also use it for boot volume for things that, you know, don't require a lot of performance, but need medium performance. Now, remember I said there's a difference between latency and throughput, and there is no such thing as a best option. In architecture, there's never the best option. There's the best option for the business and a specific use case. And that's why architects are educated professionals that get paid so well, because it's about knowing what to use, when to use it, how to use it, and why to use it, which is pretty much the same thing that a doctor would use. Why does the doctor learn 10,000 different drugs? Because it takes 10,000 different drugs to take care of your patient. And, you know, when I used to practice medicine, people would say, Mike, what's the best drug? And I'd say, for what? So if the question pops up, and it always does, which is the best one, there is no best one. There's the best one per use case. There is no best anything. We architects have to analyze the available evidence and then choose the solution. So now let's talk about an environment where you need a little bit of throughput. And what could that be? So let's say you've got an environment where you're dealing with large video files or audio files or big software things, big stuff. Well, if you need it to be local to the hard drive, to the server, here's where you're getting into this EBS throughput optimized hard drive. Now, this is going to be magnetic storage. So when we're dealing with magnetic storage, guess what? Latency is high. Remember the old hard drives? I've got a RAID array sitting with 12 of them sitting in my data center right now. And here's what it sounds like. Constantly writing. Now, the latency on this thing is terrible, but my throughput is okay. So throughput optimized gives you about 500 megabit a second of throughput. Guess what? That's pretty rock solid. In fact, that's about equal to a standard SSD drive and is twice the speed that you're actually getting from an EBS general purpose 2 drive. So, I have to absolutely say this, that it's just unbelievable, unbelievable, unbelievable. So, these are the things that we're excited and we're looking at. So if you've got an environment where you've got to store a lot of data relatively cheaply, and you need to be able to access it relatively quickly, not from a latency perspective, but from a throughput perspective, this is awesome. This is an extremely, extremely good option for you when you've got big photos, big videos, big data that needs to be accessible by the server. Got sequential reads and writes? Woohoo, this is perfect. So, keep that in the back of your mind. Now, the last type of block storage we're going to talk about is EBS cold hard drive, SC1. Now, this is your lowest cost, lowest performance, lowest IOPS, and moderate throughput of 250 megabits per second. Only use this stuff for workloads that you don't need that frequently. So what we're going to do next is we're going to talk about how we create RAID environments to work around the performance problems of block storage. And we're going to do that next. But in a few minutes, I like to do 20 minutes of teaching, 10 minutes of questions. So, Chris, I'm sure there's some questions from the crowd. If you can bring forward some of the questions, let me know what the questions are, and I'll do whatever I can to try and get everybody all caught up. S3 is object storage. So it's very similar to cloud storage on Google and Microsoft Blob as well. What's the best EBS volume on AWS? So when it comes to architecture, there's never a best anything. There is best for the environment. So when I used to practice medicine, someone says, what's the best antibiotic? And I'd say, there is no best. And they said, what do you mean? I'd say, this one covers Pseudomonas. This one covers a gram-positive thing. This covers a gram-negative thing. This one is when you use when you don't know. So it's the same way with an EBS volume. So if you need the lowest latency, it's got to be an IO2 device. If you need moderate throughput and low cost, it's an EPS throughput optimized hard drive. If you need moderate performance but lower latencies, you may get away with the IO1. So it's really based upon choosing what's in the best interest of your customer. So throughput and IRLS are related to high hops. Okay, so because I don't really understand what you're actually asking. Throughput is the amount of stuff you can carry. So 10 gigabit per second, 100 gigabit per second, that's throughput. Latency is the amount of time it takes to access something in milliseconds, microseconds, nanoseconds. So late IOPS is a measure of how many times you can read and write to the disk. The greater the number of times you can read and write to the disk, the less time per second, the less time each write takes. Can we share the different storage again? What we can do is you can go to a chart inside of our book, or you could go back and rewind these things because it took us 20 minutes to cover it. And if we go over it again, we're going to be in the same situation. But IO2, highest IOPS. IO1, second highest IOPS. GP2, third highest IOPS. Magnetic storage, lowest IOPS. And then cold storage, by far the lowest. What's the difference between elastic block storage and elastic file storage? We're going to get to file storage too, but here's the thing. Block storage is a storage area network where you take your data and you break it down into blocks. And that blocks can be anywhere in the environment. So that's what we're doing on with block storage. File storage is when you have to share something with a bunch of devices. So file storage is used for servers. And we'll teach you about the Sun Microsystem / Oracle network file system, which is what we use everywhere. And then AWS just made a proprietary version of that. So what's the one for big videos and photos? Well, it depends. So are you distributing your big photos and videos? If so, use object storage. Now, if those devices need to be used by a server, then it's going to go on block storage. So for big videos and photos, it still depends. If you need extreme throughput, you might still use the provision IOPS2 volume because you might need that 4,000 megabit per throughput if you're constrained on how long it takes. If you're not constrained, your probably best option is the throughput optimized magnetic drives. But it depends what the use case is. So which is faster, the storage associated with EC2 or block storage? The storage that sits in the system is probably 10 to 50 times faster than block storage, and maybe even 100 times faster. So it's not even a close comparison. That's why I said block storage is really slow by comparison to the type of storage performance you can get inside of a server. In terms of latency means do get leaves. How about high latency? So I'm going to try and translate it and make sure I understand it. The latency is how fast you can do something. So if you need to write, I'll give you an example. If you need to write to disk 1,000,000 times per second, if every order is 1,000,000 times, if you have 1,000,000 orders and you need to write to the disk 1,000,000 times per second, if you can only write to the disk 250,000 times per second, you will lose 750,000 orders, or 3/4 of it. So what do you have to do to make it work? Do you have to use a queuing system to work around the performance of the cloud? Maybe. Do you have to use RAID to work around the performance of the cloud? Probably. Do you need to do 3 or 4 things to work around the performance in the cloud to make it work right? Yeah, you absolutely do. So when you've got a high latency environment, what are you going to do? You're going to do RAID, you're going to do caching, you're going to do all kinds of stuff that you can do to try and do it. Because if you can't meet the performance needs, your applications don't do what they're supposed to. If they don't support the business, the cloud architect gets fired and the replacement fixes it. So it's a matter of, making sure you design based upon the business requirements. What is the transaction load? The transaction load will determine your IOPS. How much data do you have to move will give you your throughput requirement. Only then can you figure it out. Beyond that, it's all conjecture. Chris, you can bring in the next one. What makes S3 different in terms of EDS? So, Jude, what we're dealing with is 2 kinds of storage area networks that are completely different in the way they work. So block storage is used to mount to a server to act as a local hard drive, even though it's a network drive. Object storage can't be used by computers at all. So if you want to use something as a hard drive, it must be block storage. Now, AWS S3, and I like AWS 3, but S3, if you really look at it, is object storage. So because object storage takes data and breaks it down into objects and smacks some metadata on it, and object storage is a write once, read many times, and every time a file is modified in object storage, it creates a new version, you'll see why you can't use object storage for anything really other than software distribution, backup and archival purposes, and just storing stuff. So this is the architecture piece of knowing what to use. So if I'm going to distribute software to users all over the world, I'm going to use object storage. But if I need a hard drive in a server, I have to use block storage. Chris, do we have any others?
No, you answered a couple of them together.
Oh, great.
With the similar question, same questions from different people.
Okay, so let's get back to the content. And woohoo! I'm just so happy. I just got an email from a Mark, and he just said, hey, wait, I just got my first cloud architect job. And the Tech Interview Mastery Program just got him the job. So I'm so excited. So let me get back to the actual content.
Hey, I do want to point out, and if you can invite people to the webinar tomorrow, we've had a lot of non-bootcamp related questions that are more geared towards the webinar.
Okay.
So
please,
I'll let you invite them, and then ask them for a cloud hired.
Yeah. So please join me tomorrow on our How to Get Your First Cloud Architect Job webinar. We will tell you everything you need to know to get your first cloud architect job. I will tell you how to leverage your life experience to show the hiring manager you're capable. I will show you exactly what the hiring manager is. If you're what the hiring manager desires, you'll get hired every single time. I will tell you what needs to be on your resume. I will tell you what certifications will get you the interview, because certifications don't get you hired, but they do get you an interview. I will tell you exactly everything that needs to occur. So, Mark, we're super proud of you. On all this stuff is great, and we're thrilled for you. So, can't wait to see you back after the Easter holidays, but thrilled, cloud hired. So, that's the, you'll come to this webinar. We will tell you everything you need to know. How to tune your resume, how to skip HR, really, you should come. So I'm going to ask you to join the How to Get Your First Cloud Architect Job webinar tomorrow. It's 100% free. It'll be on Zoom. You'll be able to ask me any kind of questions you want after the one presentation, and we will spend as much time as we need to get you hired. So because we're talking about getting hired, and one of my students, Mark Lawrence, just got hired, if you can give me a hashtag cloud hired, because that makes me super happy. And then we'll get back to the tech content here. So now, how do we make this low performance stuff work? Because we want to make it work, right? Well, think about this kind of concept. If you've got one thing and it's not fast enough, what if you have two or three or four? A couple of slow things together or weak things together can become very fast and powerful when put together. Take a little twig and you can break it. Put 50 twigs together and you can't break it. It's strong. So now we're going to talk about RAID, otherwise known as redundant array of inexpensive disks. So what is RAID? RAID is a way to take multiple disks, physical disks like hard drives, or logical disks like block storage volumes, and we can pop them together to create increased performance, increased speed, and increased capacity. So RAID is really cool. And I'm going to tell you this, all data centers, all their storage is all on RAID environments. So RAID gives us improved performance and redundancy. Now, realistically, there's lots of versions of RAID, but they all come from one of the following: RAID 0, RAID 1, RAID 5, and RAID 10. Now, I'm going to tell you, 99% of all enterprises are using RAID 5 or some flavor of it. We can't do RAID 5 on the AWS cloud for the following reason. RAID 5 introduces some additional latency, and block storage is so pathetically slow. Performance is so bad, we can't afford to add the additional latency. But since you'll be migrating things from RAID 5 to the cloud, you need to know RAID 5. So we're going to talk about RAID 0, RAID 1, RAID 5, and RAID 10. So we're going to start with RAID 0, everybody. RAID 0 is fast. So you have 4 hard drives. What is RAID 0? Send the data to drive 1, drive 2, drive 3, drive 4. So 4 2 terabyte hard drives. Guess what? 4 times the speed and 4 times the performance. Pretty cool, right? Oh, sort of. And I'll tell you what the problem is. So now you take 4 disks and you write the data on 1 disk, 2 disks, 3 disks, 4 disks. 25% here, 25% here, 25% here, and 25% here on the 4th disk. The 3rd disk fails. You only got 75% of your data. It's all dead. You lost everything. So RAID 0, super fast. Great capacity. But if I've got my stuff split on 15 hard drives, and if one of the 15 hard drives fails, I lose everything. When you use RAID 0, backup is your best friend. I'm going to say this. If you use RAID 0, backup, and back up some more, because I promise you, you will get burnt. Now, this is what it's going to look like. When you're dealing with RAID 0, it combines your 2 hard drives together. So if we store our first block of data on hard drive 1, we're going to store our second block of data on hard drive 2, third one on hard drive 1, fourth one. So what you can see is it's like a fast load balancer. Here. And by doing that, we get lots of speed and performance. Okay, so now instead of going to Best Buy and getting a $150 NVMe drive that we stick in our server, now we go to AWS and we take 4 But the provision IO2 things would probably cost us 10 grand a month each instead of our $150 drive. And we take 4 of these fancy disks and we stripe them together. And guess what we now have? 1 million IOPS, just like we had in our drive that we bought from Best Buy, Computer Discount Warehouse, or Amazon for about 150 bucks ourselves. Now you see, all that slow cloud things, we fixed it and life is good. So kind of keep that in the back of your mind. RAID 0 is fast, 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 fast. And it's widely used. Now there's a problem with RAID 0. If we lose any of the hard drives, we lose everything. So for the most part, RAID 0 by itself is too risky. Imagine having 4 people in a company. If one of them leaves, the company goes bankrupt. Not survivable. So that's what we're dealing with. So RAID 0 is fast, but by itself, it's not reliable enough. So let's talk about the next kind of RAID. You know, I've been setting this kind of RAID up for years. RAID 1 is called disk mirroring. And for people like me that are obsessive, compulsive nut jobs with making sure we don't lose our data, we love RAID 1. So here's RAID 1. Got a hard drive and a second hard drive, or an EBS volume and an EBS volume. As soon as I write to drive 1, it automatically creates a mirror image on the second disk. Wow, this is really cool. So if I lose this hard drive, guess what? I got another with identical data. So this is really cool. But, you know, it's not without its drawbacks. What are the drawbacks? Well, if I need 10 disks in RAID, if I need 10 disks in a RAID array, then I need 10 disks in the RAID 1 backup. So I've got 1 disk, I need another disk. So it costs twice as much. You have double of everything. So that gets kind of expensive. It's not fast because when you go right from one drive to another drive, you don't get any additional speed. It's just backing up in real time. Now, guess what else is really going on when we're talking about this? It's slow because it takes time to write from one to the other. And of course, it's expensive too. And the reason it's expensive is as follows. Twice as many drives, 2 times as many, twice as many drives. So that gets expensive. Now think about it this way. You've got a 10 gig volume or a 10 terabyte volume and another 10 terabyte volume. What's your size? 10 terabytes. So RAID 1. Super redundancy. Slow, expensive, and no boost in capacity whatsoever. So this is what it's going to look like. Hard drive 1. Notice you write block 1 goes straight to the other block 1. Block 2 goes straight to the other. It's just being replicated. So it's like cross-region replication of your S3 bucket, but it's going from hard drive to hard drive nonstop. Now here we'll get to the next version of RAID. Now I'm going to tell you, this is my favorite version of RAID. I'm going to tell you that every company in the world does this, but your AWS won't allow you. So I'll tell you what it is. I'll tell you why it's my favorite. I'll tell you why I run my business on it. And I'll tell you why 99% of organizations run their business on RAID 5. RAID 5 is the coolest. It gives you speed and redundancy at the same time. Now, RAID 5, and we'll get into it, requires a minimum of 3 drives. And it gives us lots of speed and redundancy. And that's why it's used by everybody. But we can't use it on the AWS cloud. And I'm going to show you why. The reason RAID 5 is just so cool is as follows. In this environment, we have 4 hard drives. So what we're getting is we're going to be using, the way we're going to do this, we're going to put data on hard drive 1, data on hard drive 2, data on hard drive 3, and then this stuff called parity, which is backup information on drive 4. Now, the next time we put the data on drive 1, drive 2, now we put our backup or parity data on a different drive, and then the next time we write a block, we add backup data to this drive, and then a block, and then we add backup data to this drive, and then data, data, data. So by doing this, what happens? We get to use 3 out of the 4 disks for speed. 3 out of the 4. Now, if we have 10 disks in here, we get to use 9 of them, and 1 becomes backup. So what we're doing is we're building an environment where we can lose one of the hard drives in the array, and we still have access to everything. So here's what would occur. So for example, let's say we had a bad outage or a bad problem, and this killed this hard drive, and it's gone. You can see it's gone. We lost hard drive 1. What do? We open up the box, we pop in another hard drive, we push a button called rebuild, and then instantly it copies all of this backup or parity data onto the main drive, reconstitutes the data, and now we're back and we lost nothing. So RAID 5 gives us speed because it enables us to get right to more disks. It gives us much better throughput. Now, why can't we use RAID 5 in AWS? Well, remember, if your provision IO1 device is 64,000 ops, which is pathetic and more than 15 times slower than that $150 drive we can get at the local computer store, now writing latency to stupidly, pathetically drives and backup data would take too much time, which is why RAID 5 doesn't work on AWS. Now in the data center, it works great because we're not dealing with low latency. We're dealing with low latency environments already and non-shared environments. But on the cloud, it's too much latency. And that's why we don't do RAID 5 in the cloud. So if RAID 0 gives you incredible performance, which we love, and RAID 1 gives us the perfect availability, and RAID 5 gives it to us in the data center, but we're not in the data center, now what do? What if we could combine the speed of RAID 0 and the redundancy of RAID 1 in something together? Ding, 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 ding. That's the solution, and it's called RAID 10. Now, RAID 10 is expensive, but it's fast. And when we have to deal with slow storage from a, realistically speaking, cloud environment of block storage, RAID 10 is where it's at. It's super cool. So I told you that RAID 0 was cool because it gave you the speed. You got 4 drives. You write to all 4 drives. 4 times the capacity, 4 times the speed. But I also told you with RAID 0, you lost one of those drives. Ding, you lost it all. So do we really think we can build a business upon losing any of our data and losing everything? Of course we can't. It's a disaster. So because of that, we use RAID 10. So by doing this, we create a RAID array, let's say 4 drives in RAID 0. Now I build a backup RAID 0 array. Now what do? We copy from the one RAID array to the other RAID array in real time. Now we've got speed, performance, redundancy, and throughput. It's the best of all worlds. But what's the downside? Twice as many hard drives, so it's expensive. Now, as we migrate towards the cloud, and as we deal with low performance cloud storage, RAID 10 is becoming widely popular, but it's the most expensive. It's the only way, if we have high performance requirements in the cloud, we can actually do it. So these RAID environments and these architectures are really about working around the weaknesses of block storage and cloud computing and virtualization to get it to feel much more like a real network and data center. So visually looking at this, here you can see we've created 2 RAID 0 environments. And you can see the RAID 0 because we've got data. And anything that copies to the RAID 0 on the left side will be automatically copied to the RAID 0 on the right side via RAID 1. So this gives you some of your best performance, some of your best throughput, and high availability. So this is an excellent, excellent, excellent solution. Now, I'm actually going to get into network file storage and file storage protocols. But before I did, because we covered RAID, I wanted to see if anybody had any quick RAID questions. So Chris, did anybody have any RAID questions while we covered that section?
Oh, you just asked. Give me a second.
Okay. But I will answer the one question with regards to Python. Before we do that, what helps us as architects is, do we have the ability to transform our customers' businesses, which mean business acumen, leadership abilities, emotional intelligence, executive presence, the ability to do an ROI model, the ability to present, sell, and the ability to read a financial statement. Knowing Python doesn't teach us how to do any of it, so it's not good or useful or valuable at all. It's no different than if you said, hey, Mike, I can play the guitar. Does it help me become a better cloud architect? No. Now, if you were a cloud engineer, Python would be critical. But if you're an architect, knowing that does not help you in any way, shape, or form, because we don't code, we don't configure, we design. Chris, you can bring in the question. What does RAID have to do with the certification? Dr. Party, I'm going to be real honest with you. The certification has nothing to do with how do you get hired. So we're trying to give you skills that can help you get hired. In the AWS Certified Solution Architect Professional, the Google Professional Cloud Architect, and the Azure Solution Architect Expert course, you will be asked about RAID. And most specifically, the reason is block storage is so slow, which means it's not good enough for half of our business needs. So in order to make the cloud work, we need to do things like RAID. So that's why we're talking about it. It is on certain certifications, just not this one. Brian McCool, sounds like for RAID 1, that a 10 terabyte of data is now 5 terabytes due to the, so not exactly. What I'm saying is if you need 10 terabytes of data, you need 1 terabyte, 10 terabyte hard drive and a second 10 terabyte hard drive to copy the data to. So a 10 terabyte EBS volume and another 10 terabyte EBS volume to back it up. That's what we're dealing with, Brian. What is the full meaning of RAID? Redundant array of inexpensive disks. And that's the thing. Instead of trying to go buy the petabyte disk that costs us, $50 million because it's impossible to find a petabyte disk, what's really more important is if we get, 1,020 terabyte disks, it's going to be a lot cheaper than buying the bigger disk. So that's what we're talking about. RAID 10 can be used in AWS. RAID 5 is not allowed by AWS because it can add some additional latency. And because the AWS disk performance is so bad, we can't tolerate any additional latency. What does AWS recommend? Well, the only options you got is RAID 0, RAID 1, and RAID 10. So AWS doesn't recommend anything. And that's the thing, Cecil. Any recommendations that you ever see written down, throw them away. Because, here's the thing. An architect does something different for customer 1 than he does customer 2 based upon their business requirements. The business describes the thing. So anytime you just see a recommendation, it's going to be wrong in 90% of cases because the customer is not exactly the standard customer that's recommended. So you need to be very careful. You as the architect make the recommendation. What is the speed? What is the performance? What is the redundancy, the availability, the throughput requirements, Cecil? That's what you, the architect, choose to decide. And every business case is different. So these are the things that you need to know. And these are the things we teach in the Cloud Architect Career Development Program. How to know what to design based upon what business. Because certification is great for getting an interview, but it stops there because it's a different career. I don't know what you mean, Elvis. I don't know what backup horizontal traffic means. I have no idea what that means. All I can say is you copy from one thing to another thing, identical things in real time. How do you decide? Well, if you don't know whether to use a virtual machine or a bare metal server, I'll tell you one thing. Don't apply for jobs until this is abundantly obvious for you. If you need access to the physical CPU, the socket, the serial number, you must use a hardware server. There is no other option. And realistically speaking, an EC2 instance is just a virtual machine. So when do you use a virtual machine? 99% of the time. Anytime you don't need the performance of the physical hardware, for example, or when you don't need, and you can still use a virtual machine if you need physical hardware. So it depends on the performance you need. Physical machine performs better. If you're dealing with an actual physical machine and it's not on a cloud, you can use local storage because it performs better. But if it's a cloud environment, you've got to use block storage, which is slower. So, it's up to you, Slijith, the architect, to determine what are the business requirements. So if I told you the business requirements was a server that had the lowest latency in the entire world, it might be a server with 256 cores and 6 terabytes of DRAM and an NVMe drive. And that's what I would use for everything for that one server. Now, if you said, Mike, I want a little more agility and I want to be doing those same things, then I'd be using the virtual machine. if I could tolerate that. But if you told me I needed the processor serial number, I need that, so it's really there. Hidayah Kumar, which AWS service is to configure RAID? Under your storage options, you have the opportunity to configure RAID. But this is not a configuration course. This is a training course on architecture. Do you have the option to select for various services and RAID levels? Yes, absolutely. And your cloud engineers will be doing it for you all the time. Do I prefer RAID 0 or RAID 10? All in all, I have no preferences of anything, and here's the reason why. I'm an architect. If I need the maximum speed and the maximum redundancy, I use RAID 10. If I'm dealing with a video editor that needs short-term temporary storage, I prefer RAID 0. If I'm dealing with a normal enterprise, I typically would use RAID 5 or RAID 50, which basically gives you, a blend of speed, performance, and capacity. But I always determine my business requirements before I pick tech. I don't have a list of 10 tech things. I'm not a technician. I don't do if this, then this. I ask the business about the business. When I learn about the business's needs, the business goals, the business's challenges, that will enable me to think of a technology solution for them. And from there, I pick the technology that best suits their business needs. So it's never about the tech. It's always about what business problem are you solving. So you're asking me a tech solution like an engineer would, which is fine. But I'm an architect, and architects don't give engineering answers. The answer is always, what is the business case? Because I'll tell you this. I will use RAID 10 for a banking client, RAID 5 for a medical client in the same day, because the medical client needs a balance of speed and performance, but the banking client can't tolerate a nanosecond of downtime. So what are we really dealing with? What is the customer telling you? So if you want to ask me based upon a specific business case, I'm happy to answer it. Then I can help you find the right one for the right time. But there is no best. None. There is no best airplane. If you're fighting in war, a fighter jet might be good. If you're transporting personnel, a C-130 might be good. If you're trying to fly 10 million or 1,000 people across across the pond from the US to England, a 747, 767, or 777 may be best. So it's which is the best product for the solution. All RAID in the Pat in the everything that you do in the cloud is all software based. And why is RAID 5 not available in the AWS cloud? Because it adds latency, and because the AWS drives are so high latency, they won't allow you to add additional latency. That's the reason. It's just too much latency, because if you start out with a bad performance and then you add something to slow it down, it's not good. JFK, I honestly have no idea what you're asking in this question, so I can't really answer that. Okay, so we got through this, so let's get into the elastic file storage. But before we do, if you guys can give us a cloud hired. Okay, and I love saying this. Sometimes if I respond to a question, it's because I actually know the person a certain way. And if I do, I try and often give some personal guidance. So just as we go through things. So now we're going to talk about the elastic file system. Now I want you all to know what it really is. For any of you who ever have worked with Linux and Unix systems in your life, you know that about 25, 30 years ago, Sun Microsystems invented a file system called the network file system. Now, all Linux And all Unix systems use the network file system. And what's it used for? So let's say I have a file server. I've got one server here. I'm the server. And I've got 50 devices that want to access the same data at the same time. We use a file server. So with Windows, we set up a Windows file server. And realistically speaking, and for Unix and Linux, we're using the network file system. So kind of keep that in the back of your mind. So the Elastic File System is the Sun Microsystems network file system that AWS made 2% proprietary, snapped a silly label like Elastic on it, and now you know what it is. So now you know what it actually is. So now let's actually talk about this. So the Elastic File System is a highly scalable network file system because guess what? It's the network file system. So we'll say it's very similar. Now there's going to be two versions of EFS. Elastic File System, the normal one, and of course an infrequent access. So what does that mean? Hey, here's what you use when you need normal network shares. And hey, by the way, here's the link for what's the word I'm looking for data that you don't require access to. And guess what? For data that you don't require access to, guess what happens? You pay to retrieve it. So keep that in the back of your mind. So we'll have the two options, which is burstable and prevention throughput. What is it? Burstable is you get whatever you need, and if there's available capacity, you get extra. Provision is I know I need this, and I'm going to guarantee it. So the difference is either I'll take the capacity if it's available or guaranteed. So what do you think you need? In most cases, guaranteed. But that's up to you. So when we're dealing with the Elastic File System, because it's a network file system, it's going to work with all those Unix and Linux systems, which means it's POSIX compatible, and it scales. Now, one of my favorite things about the Elastic File System is that it automatically adjusts to meet your needs. I'm going to tell you this. For anybody like me that set up all these environments, having a file system that just grows on demand, woo, that's pretty awesome. So love that. Now, with regards to scalable, it's got good throughput as far as cloud services go, relatively decent IOPS, and it's relatively low latency. So what's it used for? Why are we using this? Well, the key here is as follows. If you've got a bunch of servers that all need to use the same data at the same time, you could use the AWS Elastic File System. Now, what is it really? Well, what if you wanted to create one yourself? Well, you could take a virtual machine or an EC2 instance. You could mount a block storage volume to it. You could create a file share on that, and you could create your own NFS file server yourself. So what is EFS? Is basically a fully managed file system from AWS that is compatible with Linux and Unix systems. That's all it is. Now, I want to also talk about the next file system with AWS. Now, normally speaking, cloud's disk performance is really, really bad. But what if you need better? Well, we've got a couple options here. So NFS is a file server for Windows. Now, many of us have taken Linux machines and created sandbox servers and used them for server master block shares for Windows. Or what do most people do when they need a Windows file server? They get a Windows file server. So if you wanted to share files with your users, guess what? You create a file server. So if you want to build your own Windows file server, go ahead and do it. But if you want a fully managed file system for Windows, you get this Amazon FSx for Windows file server. And what is it? It's a fully managed high availability Windows file system. What is it? Hosted Windows servers for you. So instead of you managing your own, they manage it. And realistically speaking, this gives you support for Microsoft file system features such as Active Directory quotas. And because we're dealing with a Windows file server, it provides encryption and transit at rest. And it's a good option if you don't want to build it yourself. And that's one of the things people like about the cloud. It's so simple and super easy. Now, what if you needed real high performance in the cloud? and you couldn't deal with any more of the slow and pathetic traffic, but you actually needed something. Well, Amazon has a solution for that, and they call this Amazon FSx for Lustre. Now, this is a high-performance file system, up to millions of IOPS, upwards of hundreds of gigabit per second throughput. We can sync and store it on a copy of the data to S3 buckets, do very high-performance data transfers via multiple threads. This is good stuff. Amazon FSx for Lustre. So you need a high-performance file system in the cloud. That is your option. That is going to be your option. So we're going to be getting into sending your data to AWS. Chris, how long has it been since the last question? I think it's only been about 5 or 10 minutes, but I want to make sure because the next section is going to be 20 minutes.
Yeah, it's only been about 5 minutes.
Okay, then we're going to go straight into the sending data. So, okay, let's talk about sending your data to AWS. Well, how are you going to get it there? There's a lot of options, and I want you to know all the options. So the first way to get your data to AWS is very simply over your network connection. Have a direct connection, have a VPN, just transfer your data. Simple, easy, right? Now, you could just FTP all your data if you wanted, or find another way to do it. So what else could you do? You could create a server in your data center and have that server synchronize with the cloud in real time. Now, you could figure out how to do it on your own, or AWS, guess what? They have a virtual machine that you can do that's pre-built. And here's what you do. You use that virtual machine, you put it in your data center. Your devices mount that like a file server. They copy their records onto that storage gateway, and poof, it magically gets transported to the cloud. It is really, really great. So it's a virtual machine. There'll be a VMware ESXi image for most things which use VMware ESXi. There'll also be a Hyper-V image for people that use Windows servers. I've not worked with a lot of Windows servers in 20 years. I know companies that use Windows servers for email and Active Directory, and for the most part, they use Linux servers, but either way. So this is a really great way to do disaster recovery. It's a fantastic way to back up an organization's stuff to cloud, and it's really great for hybrid cloud. So when we deal with this, we're actually going to be dealing with a couple different storage gateways, and they get a little ugly and complicated, but we're going to go through all of them. Now, some of this is certified solution architect professional, some of it's above that, but I want to make sure that you're higher above and you at least understand the way things are architected. And of course, the labs, if you want to do the labs, you can always download the labs. The links are in the description below. So when we deal with this, we're going to deal with a file gateway. We're going to be dealing with the volume gateway. And there's going to be two versions of the volume gateway. There's going to be a storage mode and a cache mode. And we'll also talk about a tape gateway. And this is how you get your data to the cloud. The first thing is a storage gateway, and it is a file gateway. So basically, it is a virtual machine that feels like a file server. So guess what? NFS for your Linux systems, SMB for your Windows systems. What happens is you copy your data to this, and your files will be asynchronously copied to the block storage or S3, and they'll become objects on S3, and they'll be encrypted with SSE or server-side encryption keys. And here's what it's going to look like when you set this up. So when you set this up, what you're going to see is you're going to have this storage gateway. And what you'll do is you'll have your stuff, whether either via NFS, if they're Unix and Linux systems, or SMB, they will mount to the server. Now, what happens is this server is going to be connected over your direct connection or your VPN or your software-defined networking connection or whatever WAN you have. And when you write data to this, it's going to send it over to S3. And of course, it can stay on S3. You can pull it off on S3 and turn it into some another disk file system like an EBS file, or you can store it in our object storage until you need it. And heck, you could even send it across the wire, stick it in S3, and you could have a life cycle policy, keep it there for 30 days, move it to infrequent access after 30, and even put it in Glacier. The point is you've got a lot of tuning that you can do, and this is a really great environment to do it. So the storage gateway enables you to get your stuff to the cloud. Now, That's a great way to migrate your stuff to the cloud. But what if you wanted to use the cloud for backup, like disaster recovery purposes, which is a great use of the cloud? So here we come into this volume gateway stored mode. So let's say an organization has 90% of their data in the data center. With this volume gateway in stored mode, we keep it in our data center. And what happens is this thing asynchronously backs up our data to the cloud. So we have an EBS snapshot, which effectively gets stored on S3 of all of our data that we've got. So we're taking our data, we're storing it in the cloud because most of our data is in the data center. And it lets the cloud be able to use the data. So it's pretty cool. So what happens? We use the storage gateway. It uses the iSCSI protocol, and we mount our devices to the storage gateway via iSCSI, and it just miraculously copies the data to the cloud, and it's there for backup. And we love that. So here's what it looks like. You got an environment like this. We've got our data center. We've got this machine, and it's just creating snapshots of our data and it's sticking it on S3. Really, really, really cool stuff. We love it. And when we see these kind of things, these are the things that make us love the cloud. Make us love the cloud. Now, let's look at the alternative solution. What if an organization kept its data in the cloud? Now, remember, computers can't use object storage. Object storage is cheap. Can we keep our stuff in object storage, which we can't use as real storage, pull it from the cloud when we need it, use it, and then copy it back to the cloud? How can we do that? Well, this is where the concept of volume gateway cache mode comes in. We've got all of our stuff stored in the cloud. We've got this volume gateway in our data center, and we mount the volume gateway as a server. I want information. I go to the volume gateway, and it pulls it from the cloud. Pretty cool, huh? I always thought this was cool. And it converts unusable storage into usable storage. So I love this kind of environment. So what's this look like? Well, I'm going to show you right now. Here you got your users. Their stuff is all in here. We've got a beautiful storage area network, our data center. We connect to this device and send stuff over there. And guess what? We've got lots of storage stuff over here. All this stuff over here, we cache it over here and we receive it. So by using a volume gateway cache mode, what it does is it makes this stuff on the cloud feel local to us. And let's look about why and how this is so cool. So, okay, there's me. And right now, I want to get something from this data center. Right now. Right now. I want to get something from this data center. So what do I do when I want to get this information from the data center? I request it the first time, and it gets placed into this gateway VM. Now, I'm the guy with the blue. The next person with the green requests that same information, goes to that gateway, volume gateway, and says, woohoo, it's here, and gets it received. Now, the person with the orange shirt goes to get some data. It's not there. Guess what? It goes all the way to the cloud. It comes back, gets served. And now we've got this person in the upper left-hand corner. I can't see what color shirt they have. I can just see they've got like a yellow-orange head. Now this person comes in and they request the same thing the person in the orange shirt got. They went there and poof, it came back. So as you can see, what you're really using is it's caching the information. So the volume gateway cache mode is when the things are sitting inside the cloud data center. The volume gateway stored mode is when most of your stuff is sitting in the cloud. So now you know. So how else could you get your data there? Well, a couple other options. AWS has an option called the snowball. I don't make up these terms. What's a snowball? They will ship you a ruggedized computer. And basically it's 80 terabytes total, unformatted, about 72 terabytes usable. Now this is a big ruggedized thing and it gets shipped to you. And on this, it's got a 10 gigabit Ethernet connection. You plug it into your network and you copy your data to it. So you can put upwards of 72 terabytes in these things. So you may have to call AWS and get a half a dozen of them. What do? You copy your data to it. You crest the snowball, AWS delivers the snowball, you load your data. AWS picks up the snowball and they copy it to S3. And once it's on S3, you can pull it off and do what you want. So snowball, ruggedized computer used to transfer a good amount of data to the cloud. Why use the snowball? Well, with the storage gateway, you could send over your network connection, right? But do you have the time to send it over the network connection? That is the question. And maybe I'll teach you how you can calculate how much time it takes to send your data over the connection if you guys are interested. And if you are interested, I'll teach you. So if a snowmobile is a way to take a moderate amount of stuff, a snowball, well, what if you have to send a lot of stuff, like a lot of stuff? Well, that's where they get into the snowmobile. So AWS has a snowmobile. So if you're migrating a monstrous banking data center to the cloud, you can call AWS, and a tractor trailer will come with this 45-foot shipping container that can store upwards of 100 petabytes of data. It's a data center on wheels. It'll come to you. You'll connect to this over high-speed networking. You'll copy all your data, and then it will be driven back to AWS by a professional truck driver, and then the AWS personnel will copy your data. So snowball, about 70 terabytes of data, or we get multiple. Snowmobile, petabytes of data. What if we have a little bit of data to move? Just a little. Okay, so just a little. Well, what if you could shake an external hard drive and send it to AWS? Well, that is the AWS import-export service. What is the import-export service? It's a rental hard drive. You call them. You basically get your data. You put your data on the hard drive. You ship it to AWS, and they take it on and stick it in S3 for you. So now you know about the import-export service. Now we're going to talk about Amazon WorkDocs real quick. Amazon WorkDocs is a fully managed, secure content creation, storage, and collaboration service, like Dropbox or Google. It enables collaboration on creative projects, enables shared document editing. It's simple and affordable, and you can be accessed via the web. Our client software works with Windows and Mac clients and meets all compliance standards. I don't know of anybody that's ever using this, but here's the thing. AWS talks about it. In case it's on your exam, we wanted to cover it. So what did we cover in this chapter? We talked about this types of storage: block storage, object storage, file storage. We talked about the AWS proprietary S3, EBS, EFS, RAID. We talked about file systems for Windows, file systems for Lustre, storage gateways, snowmobiles, import, export services, and oh, wait, Amazon WorkDocs. So I'm sure at this point there's some questions, and I am thrilled to actually answer them. So, Chris, if you want to let me know what's coming in.
Yes, please give me just 1 second.
Sure. Snapshots are stored on S3. What if you have data for real-time streaming? Would you still make use of a storage gateway? Well, it depends what you want to use the data for. So if you're dealing with real-time streaming video, you probably wouldn't capture it. If you're dealing with real-time information and you want to analyze that information, you're going to use a different streaming service like Apache Kafka. So if you tell me what you want to talk about streaming data and what you want to do it, then I can tell you what appliance you use. But streaming data could have about 15 different things. So it's what do we actually want to do? And then I can tell you what to do with it. Why would RAID 0 result in all data lost? So generally speaking with data, it's either we have it or we don't. So I've got 4 hard drives. 4. I put 25% of my data on this finger, 25% on this finger, 25% on this finger, and 25% on this finger. This finger now goes. So now I've got 25%, 25, 25, but I'm missing 25%. I can't reconstitute my data if I'm missing 25%, and that's the reason why. So with data, it's all or nothing, and that's the reason why RAID 0 results in things being lost at once. Are there any upcoming cloud database software storage from AWS? That's what they recommend their EBS volumes for. Chris, you can go to the next one.
Either they're really shy or you did a really good job.
Well, there was one question that I saw that I was going to address, and it was related to how to master EC2. And here's what I'm going to tell you. EC2 can be summarized in one word or two words. The only thing you need to know about EC2 is that it's a virtual machine. That's literally seriously it. Now, I'm going to cover lots of stuff with the thing, but if you don't know what a virtual machine is, you'll never know what EC2 is. So learning virtualization and learning virtual machines is important. Learning EC2, all you need to know it's a virtual machine. And if you knew that, you'd be able to work in AWS, Azure, Google, Oracle, Palo Alto, Dell's Cloud, Cisco's Cloud, or the Alibaba Cloud. So there's nothing to learn about AWS EC2 other than it's a virtual machine. EFS is network storage, network file storage. So can it be on a NAS? Sure, if the NAS is functioning as file storage. Can the SAN be file storage? Sure. And if so, it'd be NFS. If the NAN is object storage, it would be object storage. And if the SAN is our storage area network is block storage, it would be block storage. So cloud providers use different SANs for different things. So they'll have one storage area network that's based on object storage. They'll have another storage area network that's based on block storage. And chances are they will have a bunch of file servers with 1,000,001 hard drives in them that they're using for EFS. What are the difference between Snowball and Snowmobile? Well, a Snowball can do upwards of 72 terabytes after its formatted capacity. A Snowmobile can do 100 petabytes, so a whole lot more. Tada, could you please throw more light on Amazon Workdocs? Tada, absolutely. So, we have Dropbox and Google Drive, where people can kind of use their own little things to collaborate. That's what Amazon Workdocs is. I've never heard of anybody using it, truthfully. I don't know anybody that doesn't use the Google or the Dropbox version. What RAID levels are used by NoSQL databases? Nago, what RAID levels of performance do you need? Can you get away with RAID? Do you need RAID? If so, do you need RAID 0? Do you need the reliability of RAID 1? Do you need the performance of RAID 10? What RAID levels can you use? You can use the RAID levels that the business determines you need. So, what is the IOPS requirements of the database? How many transactions are going to that web server? That's the determination of what you need. So again, what does the business tell you they need? It will always come back to the business level. What does the business need? If that person says their website does 10 million transactions per second, you need 10 million IOPS minimum per second. And if you need 100 EBS volumes to do it, you're going to need it. And if they say we have 1,000 transactions per second, you might need 1,000 IOPS, which is going to be beautiful on the cloud. So what drives all technology? All of it, 100% of it. What does the business need? So always ask the question, the question is not which tech is good. The question is which tech solves the business problem. And that's why, just to let you know, engineers have such a hard time becoming architects, because engineers are focused on the tech. And this job is not about the tech. I mean, there is one time I evaluated a business, and as I was watching what people did, I figured out an ice machine was the best thing they needed. I recommended an ice machine. The company saved a couple $1 million a year, and the next thing I realized, they bought $50 million of tech from me because I found the solution to their problem. That's what we're looking for. Can I tell you the difference between a storage gateway and a volume gateway? And like I said, all these questions are, some people are engineers and some people are architects. So for the architects, it's always what's the right thing. For the engineers, it should be that's the same question. They should be asking the right thing. And in the engineering world, we get biased into speeds and feeds, for example, and the speeds and feeds are totally irrelevant to our customers. So even in engineers, if we want to optimize our career, we need to be focused on the business problem that we're solving as opposed to the techie. So that, but even in techies, when we are techies, and I was an engineer and loved being a techie, still had to go to the business. And when I didn't, you know what happened? I was held back. I don't want anybody held back. Storage gateway and volume gateway, yes. So here's a storage gateway. Basic server, I copy it to it, and it just copies the stuff over. I use that storage gateway until my stuff's in the cloud, and then I toss it away. storage gateway. By comparison, volume gateway was different. Now the volume gateway, which I absolutely love, does things different. In the volume gateway, if it's cache mode, it's because my data is primarily in the cloud and I want to use the cloud to look and feel like storage. Of course, the alternative is the volume gateway stored, which is where I keep almost all my data in the data center, and I want to just keep it copied on the cloud for backup and archival purposes in case of emergency. And, we love these things. So kind of keep those in the back of your mind. And we just covered those storage gateways and volume gateways. So going back to it, storage gateways. Copy your data over, goes there, and you're done with it. Volume gateway, cache mode. Your data is in the cloud and you want it to feel local. Volume gateway stored mode, the predominant data you have in the data center and you want to back it up to the cloud. Chris, I saw you had another one. Nick B, you mentioned RAID 5 is not accepted by cloud providers. Is it accepted by any other? If yes, which providers? Nick B, every single day these things change. And every time I build a cloud architecture, I go and check with the cloud provider. So that's one of those things where I strongly recommend you read the documentation on every single architecture. Because, for example, last year I was talking about the pathetically slow AWS IO1 volumes. And then 3 days later, they came out with an IO2 volume, which was almost as good enough. And then for a while, I was saying to people, hey, wait, you can't use Route 53 for anything with high security. Because Route 52 didn't do DNSSEC. And for the first 10 years in AWS's environment, they didn't provide a high security DNS service. And then a couple months ago, all of a sudden they did. So the key is these things change constantly. It is a very fluid state and dynamic. You must check the vendor's documentation every single time. And that's why don't build yourself a cheat sheet of the name of the services. Google has one online. That's why we don't make in the cloud, that certain people make a cheat sheet, but it changes every 10 days. So 10 days later, you got bad information. So always, 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 with every design, check your documentation. And Chris, if there's another one before we go back to the content. What RAID configuration is the default? Fantastic question. There is no default RAID configuration. It is up to you, the architect, to say, hey, wait, what we have isn't good enough and we need to do better, and we'll choose the RAID configuration, which is the right one for our customer. So again, it goes back to that same question. What do you need to use for your customer? So Jeff, I know you're an architect and you're developing your architecture career and you're doing really great along the way. If you need the most speed, it's RAID 0. If you need the most redundancy, it's RAID 1. If you need the maximum speed and redundancy, it's RAID 10. Pretty much up to you to determine what you actually need. Debash, how important is it to know the category types? I'll tell you one thing. I wouldn't know any of them. I wouldn't recommend any of them, and I recommend very strongly you look them up. Every single time you make an architectural design, all you need to know is an EC2 instance is a virtual machine, a Google Compute instance is a virtual machine, an Azure virtual machine, an Oracle virtual machine, an ESXi virtual machine. Guess what? They're all the same. So knowing which version to use, what do you really need to do? Not worry about anybody's silly names. They're all irrelevant. What are you really doing? How many CPU cores do you need? How much memory DRAM do you need? What kind of memory bandwidth do you need? What kind of GPU performance do you need? What kind of network performance do you need? That is how you size a virtual machine in the data center on the cloud. So if I tell my students, look, we need a virtual machine with 128 cores and 4 terabytes of DRAM, my students are going to go look on their Google, and I'll say, Google it. And they'll say, Mike, on Azure, it's an M128S V2. And I say, okay. And then my students will say, hey, on AWS, it's an X1E.32 XLG. Guess what? I don't know that in my head. I mean, I do know it because I've done it enough times, but I wouldn't remember it. Why did I remember it? Because for a period of a month, I asked my students to design something on big servers. So that's the key. It's just a virtual machine. Vickers, can you reduce queue time for what? Queue time on the egress of a router, queue time in an Apache Kafka queue? I don't know what you mean by queue time. Could be lots of different queues. Okay, so I guess we'll get back to the content and we'll start talking about some computing on AWS. So when we're dealing with AWS or any cloud provider, 99% of the computing we're dealing with is virtual machines. Virtual machines. So that's all we're talking about. And AWS, they call their virtual machines Elastic Compute Cloud. Azure calls them virtual machines. Oracle calls them virtual machines. Google calls them Compute Engine Instance. Virtual machines. So, of course, all these providers have their own stupid names for 8 million of these things. They got name after name after name. A, B, G, C, P. Okay. How many CPU cores do you need? How much DRAM do you need? How much storage capacity and performance do you need? And what does your network performance look like? And do you need GPU in there? That is how you determine your virtual machine. So, look, here's a little pretty chart of the AWS things that's in the book. You can look at A being ARM-based, G being GPU-based, et cetera, et cetera. And you can look at this and you can learn this. Personally, I wouldn't waste my time on this. I would focus on knowing virtualization, knowing what hypervisors do, how they manage the memory, the real stuff that you need to know to be good at your job. And I go to the AWS cheat sheet, which they put out for you completely free, to go look this stuff up on every single architecture. And here's why I would never memorize this, ever. If you do, and AWS changes the names, you're going to build a bad architecture. If you're an architect, if you're an engineer, you're going to select the wrong one when you're building it. So don't waste your time. Check it every single time. So because you're dealing with virtual machines, what kind of operating systems can your virtual machines do? Well, Windows and Linux. So now AWS did come up with something they called a high availability mission critical device, which was a joke, and it's a Mac OS EC2 instance. It runs on Mac Minis. The reason I say it is a joke, a high availability system has 2 power supplies. It has error correcting DRAM and special CPUs that use error correcting DRAM. A Mac Mini does not do any of it, so it is not considered a high performance mission critical device from anybody in the world other than AWS. So it's not a redundant device. It's not high availability. But AWS does have the ability for you to use a Mac Mini if you had to compile, if you're a software developer that had to compile some code on a Mac. And when we're dealing with virtual machines on the cloud, we can use pre-built virtual machines. And it's pretty easy. When I start a Linux thing, click, 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 poof. Now in the data center, we've got to go to our systems. We've got to create a virtual machine, select CPU, select DRAM, select disk. Then we have to install the operating system and many of the applications. That's what we do. But on the cloud, we can click 3 buttons and it's done. Now, what we're doing, realistically, the way things, now in VMware ESXi or most virtualization, we make a machine image of it. And what is in the image is exactly the full hard drive of the operating system, of the whole server. Everything is inside of an image. Now, all virtual machines are this way. So, for example, we've got a VMware ESXi virtual machine in a data center. We can take an image of that and just send that image to the cloud and boot up the machine. They'll call it an Amazon machine image, but it's just a virtual machine image. And what happens is a virtual machine image will include a storage volume, maybe like a block storage type, and I'll have an instance type, like at the kind of computer. You take this, it turns directly into another virtual machine. So if an Amazon machine image is just a virtual machine image that can turn into something, there's 2 ways you can do, a couple ways you can get them. Well, AWS has pre-made virtual machines. Click here to launch a Red Hat Linux virtual machine. You can do it. Now, what if you need a high security device, like a firewall? Really, you're going to go to the AWS Marketplace. Or a real intrusion detection prevention system. Or you need a load balancer that has much greater functionality than the ones provided by AWS. you're going to get them from the AWS Marketplace. And that's going to be a machine image, that's an appliance, an Oracle database, a VPN concentrator, a Cisco firewall. All your heavy-duty security stuff is going to be coming from the Marketplace, pre-built systems. And of course, you can make a machine image of your own servers. Take that server running in your data center, make a machine image, and carry it to the cloud. Or you can make a copy or a backup of one of your systems you built on the cloud. These are how you get your servers or your virtual servers to the cloud. So what are the AMI components and the machine image components? It's an operating system, Windows or Linux, launch permissions, and a block device mapping that specify volumes that we attach to the system. Now, Amazon machine images can be copied to different regions because really it's just an image or a snapshot of the routine. So think about it. Take your VMware ESXi thing, convert it to an Amazon machine image, launch it in US East, make a backup of it, and then go launch it in Japan. No big deal. So machine images are beautiful. They enable disaster recovery. They enable us to move to other clouds very easily. So really great for migration. And when we're dealing with Amazon, we've got Amazon Linux 2 and Amazon Linux machine images that are pre-built and supported by AWS. So you don't even have to install Linux on the cloud. It's all the work is done for you. So the cloud providers made it so easy for us that instead of installing an Ubuntu server or Red Hat server or a SUSE server, we click 3 buttons and it's done. Now, because AWS has systems that boot themselves and are already pre-made, that's half of the battle. But we need a system, we might need to install something. So let's say I've got a Red Hat Linux system and I want to turn it into a web server. I have to install the Apache web server. It doesn't come in there. So what I can do is I can basically create something called a bootstrap script. So let's say I've got a Ubuntu Linux system come up, and on its first boot, I want it to update itself. So I write a little script and it says sudo apt-get update, sudo apt-get upgrade. And as soon as the system, sudo apt install Apache, sudo apt install this. So what I can have that system boot up, install everything automatically from that script, and then I've got a fully operational system. So think about this in an auto-scaling environment. I got a web server. I need more. We grow them, and they come up fully designed on their own in minutes. Pretty exciting stuff. And with Linux, we can do it with this simple shell script. Now, bash scripts and shell scripts work on Linux, but they don't work on Windows. So Microsoft invented something called the PowerShell. And guess what? On the PowerShell, we'll write PowerShell scripts for Windows. It's the same thing. This is the same way we automate stuff in the data center. We're just doing the same thing in the cloud. So kind of keep that in the back of your mind. This is nothing new. We've done all this stuff for 20 years in the data center. Now, as I mentioned, there's really not much known more about EC2 than virtual machines. And hold on one second. So when you do these, there's 3 ways you can purchase your instances. And you can purchase them via on-demand, meaning you pay for them when you use them by the second. So think about this. You've got an environment. Here's why people like the cloud. Here's the reason. People like the cloud because they pay for what they use. So I go to the cloud. I have no idea what my business is going to be. I set up some on-demand instances. What happens with on-demand is I pay the most for them because I don't know if I'm going to need them for a minute, an hour, or a year. But we use these things. If I need capacity, we can add capacity, add servers via auto-scaling. And Frank, is that better for you? And kind of keep that in the back of your mind. So with regards to on-demand instances, we're paying by the second. It's ideal when you don't know how much capacity you're going to use. Now, that's great when you don't know, but you're paying heavily. You're being penalized for not knowing because Amazon can't place bets. Like if you can tell Amazon, I'm going to buy this server for the next 3 years, they say, okay, I know what your usage is. They know how much capacity to buy. So while on-demand gives you flexibility, it's the most expensive option. So if you don't know how much to use, excellent, it's really great. But if you do know how much to use, not so much. The next thing we'll talk about are reserved instances. So what are reserved instances? This is where you tell Amazon, I'm going to use this thing for a year or 3 years. So it's committed use, right? So if you guarantee to use a certain amount of services from AWS, guess what they're going to do? Give you a discount. So if you know that you need 2 servers with 128 cores and 4 terabytes of DRAM, reserve them. Might get you 30, 40% cheaper. So that's reserved instances. Now, what if every Friday, Saturday, and Sunday, you need a batch job to run? And it runs every Friday, Saturday, and Sunday for 72 hours, and you can predict it. Well, you could do that via on-demand instances, but remember, that's the most expensive. Or you could do something called scheduled reserved. And what is that? Amazon. Every Saturday for the next 3 years, I need to use this much capacity. Okay, my character discount, because we can predict you. So that's what that is. So on-demand, most expensive. Pay for what you need. Reserved, you pay for it as soon as you provision, you guarantee them a certain amount. Scheduled reserve, you guarantee every Friday and Saturday I'm going to use it. So let's talk about the next 2 options. A spot instance and a dedicated host. Well, here's what a spot instance is, and this is the scariest thing ever. You rent a virtual machine from AWS, you bid on it. Okay, there's leftover capacity and I'm going to build this cheap price to pay for it. And Amazon says, cool, we'll accept your money. And then somebody else says, I'm going to pay more by 1 penny than Mike's willing to pay. Amazon says, Mike, your systems are all shut down right now. Somebody paid more than you. So that's a spot instance. So if you're working on a computer project and it can start and stop and you don't care, spot instances are great. But if you have something that matters and AWS can just shut off your servers if they've got more money options, this is not good. So keep that in the back of your mind. Now, I'd say the last thing we'll talk about is the dedicated host. Now, a dedicated host is just a real server. So if you need real system information, you must use a dedicated host. There are lots of softwares that have a card that needs to be plugged into the motherboard, into a USB port to show for the license. You need a dedicated host for that. If you need physical bare metal, you need a dedicated host. So how do you determine what you need? Because the question was asked, and it's a good question. Well, if you don't know what you need, it's got to be on demand. If you need max performance, it needs to be a dedicated host. Because once you use virtualization, it kills your performance by 10%. If you've got something that you know is going to be capacity you're going to use all the time, use a reserved instance. And if it's something that you're going to do periodically, like 2 days a week, every week, use a scheduled reserved instance. If you don't care about it, when you want the cheapest, use a spot instance and use a dedicated host when it really matters, because it's a regular server. So let's talk about how do you secure your EC2 instance. Well, an EC2 instance is nothing more than a virtual machine. Now, what if there was some kind of fancy security service that you could use to keep traffic in and out of virtual machines, like a host-based firewall? Well, in that environment, there is something that's called a security group. And all a security group is a stateful firewall that gets used to protect traffic from going in and out of an AWS service. So you can put a security group on a server, and I'll show you what it looks for. Let's say in this particular environment, I've got a couple of servers. Now, we use the term instance because that's the AWS term, instance. Realistically speaking, it's a virtual machine. That's a more appropriate term. Your CIOs, CIOs will know what that is, but they won't know what an instance is. So don't use that term with your customers. So when you've got your virtual machines over here, you've got a security group. So let's say this is a web server. This security group can say only ports 80 and 443 are allowed in. This server can be a DNS server. Only allow TCP and UDP port 53 in. So realistically speaking, that's what a security group is. It's a host-based firewall to get into a system. So how does a virtual machine get an IP address? Well, how does it work in a data center? Two ways. You manually assign it, or you get one via DHCP. Now, when we bring up systems on the AWS cloud, they automatically get an IP address. They're also given a DNS name from AWS, which means you'll be able to connect to it via a name or an IP address. Now, if you want to reach a system on the internet, somehow you will need a public address on that system, either on the system itself or on the load balancer that's in the front end of that system. If you have systems that you don't want reachable from the internet, they get a private IP address and they won't be reachable from the internet. And make sure they're obviously behind firewalls, VPN, IDS, IPS systems, et cetera, et cetera. Now, instances are automatically assigned an IPv6 address, and all of those are public addresses. They're globally routable. There's no concept of private addresses in IPv6. But we can manually disable that at launch, so we don't have to get an IP address. Now, here's the thing. Every interface on a server and the data center on the cloud needs to be on a different subnet. Keep that in the back of your mind, and the subnets can't overlap. So, you can access your systems to manage them via the EC2 instance, via the secure shell for Linux machine, remote desktop protocol for Windows, and of course you can perform some management via the software development kit, meaning the API. So what have we discussed in this section? We discussed EC2 instances or virtual machines. We've talked about virtual machine images. We've talked about purchasing options, tenancy options, securing EC2 addressing, and addressing and managing of EC2 instances, otherwise known as virtual machines. So, Chris, I don't know if many questions came in. I saw Frank had a question. I hope I slowed down for him because I really wanted to help out there. So, Chris, if you want to let me know what kind of things have come back in. Please forgive me for this question. Can I differentiate or link these components through an architecture diagram, root volumes, instance store, volume AMI S3, and EBS volumes? So, very simple. You got an EC2 instance, which is a virtual machine. The root volume is the main volume, but all Linux systems have multiple drives or multiple partitions, and they're called volumes, and that's all it is. So you can have 50 volumes, and you can call your volumes anything you want. Think of it this way. Every hard drive or every hard partition is a volume. So there's that. Now, perhaps there is that. So all a virtual machine image or an AMI is an image of a virtual machine. So it's an identical copy of the virtual machine mapped as a single file. So kind of keep that. And the other two parts of the question I can't see because the question went away. And object storage is object storage. Object storage is used for our storage and archival purposes. And we covered that extensively yesterday. And EBS volumes are just simply block storage volumes, which are used as volumes that you'll be placed inside of your Linux and Unix system, Linux and Windows systems. And who knows? Maybe we'll have a little special fun architecture challenge next week. We'll see. Chris, if you want to go to the next one. Up and running. I have honestly no idea what you're actually asking me. A simple shell script is a simple shell script, so I don't even understand the question. I'm sorry. Question: are the machine images hardened out of the box, or do you have to harden the images themselves? There's no such thing as a fully hardened image. You always have to do system hardening. Now, here's the reason, and this is one of the 18 million reasons we don't recommend Bastion hosts. Most people will never know how to harden a system properly. Now, there are companies, for example, like Palo Alto, that know how to do system hardening, that make custom operating systems for the devices that are hardened. But no, nothing is hardened out of the box until you do it. So your people would need to be really good at knowing which services disable and which ports to close and what anti-malware protection needs to be there and what endpoint protection needs to be there, et cetera, and this goes on. So it's incumbent on you to do all the hardening. There is nothing on the cloud that's done or secure by default. It's all a misnomer. The cloud is slightly less secure than the network in the data center. It has every single attack problem that the network and data center has, along with a few more, meaning it's the biggest high-value target in the world. Here's why. Hacking AWS, get access to all their customers. Can I share an instance with partners? I don't know what you mean. Can I make a copy of my virtual machine and share it to a partner? Sure. In fact, if you go to the AWS Marketplace, you'll see when we get to security, we'll talk about some AWS native security services. And I'll also tell you, Beverly Burnett, you won't be using any of them in your career for the most part. You're going to be using more industrial grade and enterprise services. And they're all going to be an instance that's going to be coming out of the, what do you call it? The AWS Marketplace. And from that, it's going to be a pre-made virtual machine. So yes, you can make a pre-made virtual machine and share it to somebody else. But you've got to be very careful. You don't want to make a virtual machine and give it to somebody else that's got your proprietary stuff in it. So for example of that. A dedicated host is an actual server. A dedicated instance is a machine. So a dedicated host is one server that has all your virtual machines where you placed on it, and a dedicated instance is a special virtual machine that's just yours, if I remember correctly. There's not that much of a difference. How do spot instances really go behind the scenes? Are they limited in the number that's going to the bed hotter? Exactly. So here's the thing. AWS has extra capacity. Google has extra capacity. Azure has Google capacity. Azure calls them presented images. So, you know, that's what we're realistically speaking and talking about. So all it is you bid for something, and all of a sudden Joey bids a penny higher than me, and all my stuff is shut down. So realistically speaking, that's all we're talking about. How are the license of the OS handled? Well, it depends on the OS you're using. If you're using the ones in the cloud providers, they come with a license, as a rule. Some of them require better licenses, and you have to pay for the license. It's handled the identical way that it was handled in the data center. Nothing's changed, not one bit. If you need a license for Oracle, you can bring your own license, which is the best option, or you can use the AWS license, and then they charge you for it. But in any case, you're paying for the license no matter what. Okay, how is a container different than a virtual machine, which is really the question you're asking? Well, a virtual machine is where you take a server, you install a physical hypervisor, and then you chop that server into multiple virtual machines. Each virtual machine will have its own operating system, application dependencies, and applications. A container, by comparison, is where you take a server, install an operating system, and install a container engine, and then effectively virtualize that operating system to multiple isolated systems all on the same things. And we've got a video on this. So what we can do is my team will post a video of the link between the difference between a container as well as a virtual machine. And Johnny, if you do that, you will know what to use for AWS, Google, the data center, Azure, as well as the Oracle and the AWS environment. You'll know it all. Is there any other alternative to AWS Workspace? Personally, Tunde, I've never seen anybody in the world use the AWS Workspace. I've seen everybody else use Google Drive and Google Documents or Dropbox. That's the only thing I've ever seen people use in my life. Can a virtual machine be ported? Absolutely. So here's the thing. I create a virtual machine in VMware ESXi. I bring it to Azure, Google, Oracle, it's the same thing. It's no big deal. But as a rule, I would probably create it in my data center and then port it to everything else. And in most environments, Kieran, I will take the same virtual machines and make sure they link the same virtual machines and use them in 2 different cloud providers at the same time for high availability, high performance, and high security requirements. So, a lot of these questions are actually answered deeply in 20-minute to 2-hour videos on our YouTube channel. So you want to know about virtual machine versus a container, you'll see it. You want to know what virtualization is? I've made a video where I've taken a VMware ESXi server and I've created all the virtual machines and showed you how it works so you know how to do it. And I love these questions you're asking. And I'm thrilled to take them more and more and more. I love answering questions. I truly love it. But I want you to know that we've got 100+ videos on our channel. And we've got videos on securing your environment, connecting them, how to really do it. The things that aren't just AWS training, the things that are, how you would do it if you really wanted a job. So we have both things. So love answering questions, and I'm going to keep answering them because it's fun. Just want you to know you've got a lot of access to good data and a lot of good training there completely free. So before we get to the next content, if you can do me the following, if you can type #CloudHired and #CloudArchitect all at the same time, it'll give me a happy day. And then we'll get back to the content. We're going to start talking about databases, which are really, really cool. Okay, CloudHired over there. James, fantastic. Karen, CloudHired. Leonardo, Cloud Architect. Leo, good to see you. Ruth, CloudHired. Ibrahim, CloudHired. Karen, Cloud Architect. And I love that. And Claudette over there in South Africa, fantastic. Vinesh, Cloud Architect and CloudHired. Sujith, I'm loving it. Sanchin, wow. Julia, so happy to see you. Sig Wolf, Cloud Architect. Sebastian, I'm loving this. See, this is music to my ears. Why we're doing this is to get people hired. Cloud architects, cloud engineers. Ciao, always nice seeing you. Lawrence, okay, fantastic. So we're all having fun. We're dealing with cloud architecture stuff, and now we're going to talk about databases. So, and actually, before we do that, if you can help us out with the algorithms and hit the like, if you liked it, if you're not a subscriber, if you can subscribe, if you want to tell others and friends, we really want to grow. We have a great company that gets our people hired every single day. But, for us, we also like to know that we can help others build their careers. And I'm going to tell you, we may have some Azure training coming real soon. So subscribe and hit the bell. And you'll need to sign up. So we have a lot more exciting stuff coming for you guys very soon. So let's prepare to talk about some databases, and let's have ourselves some fun over here. So when we start talking about databases, let's talk about what is a database. So, a database is a means to store large amounts of information. So why not just store it all on a hard drive? Well, here's the thing. I know lots of customers that have tried. They've just dumped everything onto a hard drive and then they need information and they can't get it. So what it makes a database so special is it not only provides storage, but it facilitates sorting, calculating, recording, and even information sharing. And in today's world, the database is a critical component of all modern applications. So it's critical stuff. So when we're dealing with databases and the cloud, there's a couple different environments we're dealing with. We're dealing with relational databases. We're dealing with NoSQL databases. To some degree, we're dealing with data warehouses. And we're going to talk about data lakes. Now, this is a section when we talk about this, we're going to tell you databases on the cloud. And then we're going to tell you which one of these services are going to get you in trouble when you want to go multi-cloud, because this one's a little bit tricky. So I'm going to tell you first the certification piece, and then I'm going to tell you the reality piece, because I'd like you all to be hireable in the end. So when we're dealing with databases and AWS, we're going to start with relational databases. And here's the thing. Relational databases work with information that's related to each other. So it's kind of like a spreadsheet. You got a column and a row, and data is related to each other. And that's really what we're talking about. We're dealing with a key value pair, for example. Let's not go there. Now, when we're dealing with the relational databases, we're talking about something being atomic. Oh, God, I hate getting into these things, but it could be a test question. And they're called atomic, and they adhere to something called the ACID model. And this is what this means. And if I write the information to the database right now, as soon as I wrote it, if 1 million people in the world are looking at the database at the same time, they get access to the data right then, right now, like that. So ACID refers to atomic, meaning the transaction happens or it doesn't. Consistent data, meaning the second I write to that data, it's consistent everywhere. The transactions are isolated, meaning Billy Bob's transaction doesn't affect Joey and it doesn't affect Sally. And these transactions are durable, meaning data in the database will not be lost. So that's your relational database. But when we really look at relational databases, what's really going on is we're identifying the relationship between variables. Price, email address, order ID, etc. And why are we doing this? Why? Well, if we can help a business find out that at price X, they sell Y, and at price Z, they charge price that something different, we can figure out where that intersection is, where that company makes the most money and profit. And that's why we're using databases, to get data so we can make better business decisions later. When we talk about databases, we're going to be talking about the following ones: Amazon Aurora, MariaDB, Microsoft SQL Server, MySQL, Oracle DB, and Postgres. I'm going to start with the Aurora database, which is an excellent database, which I can't use ever. And I'll tell you why I will never use Amazon Aurora and why I don't recommend ever using Amazon Aurora unless you're dealing with a specific use case. But Amazon Aurora is an Amazon database. It is a fully managed relational database, and it is an excellent database. It's compatible with MySQL and PostgreSQL. It's got relatively good performance. AWS will tell you it's 5 times faster than MySQL and 3 times faster than Postgres. But what's good about this database, and there's some very good, it gives you some of the features of an enterprise database like an Oracle, and you're not paying for it. So for that, it's good. Now, this is fully managed from AWS, meaning it's serverless. You just store your data there, and it's good. So why won't I ever use Aurora in anything? Well, see, it's Amazon proprietary, which means once I use Amazon Aurora, I'm stuck in Google and I'm in trouble with Azure. So for me, this is a product that's perfectly great for the trash can and not for use in architectures. Now, if I had a customer that said, hey, Mike, I'm looking for the cheapest, simplest solution. I don't care if my systems go down for 3 days each year, so I don't want multi-cloud. I would say Amazon Aurora is your thing. But I don't have customers that say, I don't care about my business. I don't have customers that say, if AWS raises my rates, I'm going to stay with them anyway. I have customers that want agility. They want to get on and off the cloud. My customers all do multi-cloud, and all of yours will too. So Amazon Aurora, proprietary database, serverless, stick your data there. Excellent database, but you are locked into AWS, and it will be really, really, really hard to leave AWS. So if AWS overcharges your customers, you're stuck. If AWS has an outage, you're stuck. If you don't like your service with AWS, they're stuck. Or if, like, one of the companies that AWS decided to kick off their network because they didn't like their business decides to kick you off, you're stuck. All your stuff's now sitting in some proprietary thing. So now you know the good and the bad of using Amazon Aurora. Excellent database, really good, seriously, in all ways, but proprietary. So understand that. Now, if you, by comparison, you can use MySQL as a database on OSPF. MySQL, which is now owned by Oracle, is open source. Widely is one of the most popular relational databases in the world. Guess what? You can run this on Azure, Google, and AWS all at the same time. Great database. How about Postgres? It's another open source relational database. Very advanced feature set. You can use it on all three clouds. MariaDB. That's another open source, beautiful relational database. The people that made MySQL, which is everywhere, created MariaDB. And it's basically MySQL with extra features and enhanced functionality for enterprise environments. You can get that too. Run it on three clouds. How about Microsoft SQL databases? Well, is it proprietary? Yes. Is Microsoft available everywhere? The answer is yes. So Microsoft SQL databases are good. So you can run them in AWS, Google, and Azure. So definitely in our multi-cloud plan. So it offers tools like the SQL Management Studio, and AWS, their database service supports multiple versions. So SQL Server 2008, 2012, 2014. And when you've got users that have Windows workloads that need that Microsoft SQL Server, this is a beautiful system, high reliability, easy migration, because we're dealing with the same tools that are there. Now, Microsoft has lots of different clustering and failover options. They're very different the way they work than traditional relational databases. And there's 4 versions of this: the AS Express, the web, the standard, and the enterprise, and you can use all of them. Now, I'll tell you this. In the last 20 years, 25 years, I'm going to tell you, 90% of my customers all use Oracle database. One of the most popular databases in the world. Huge feature set. And guess what? You can use it in AWS, Azure, Google, and the data center all at the same time. So perfect for multi-cloud. And AWS supports the standard license, the enterprise license, the standard 1 license. And you've got lots and lots and lots of options here with flexibility and scalability. And we've got a couple licensing options here too. So, there's the 2 versions. You can use the license included in this, where you buy your thing from AWS and it's licensed to AWS, and then they charge you to use it. And you've got your 2 options here. It's basically your standard edition 1 or 2. But let's say you've been using Oracle for a while and you have a license. Guess what? Bring it with you. Now you've got more flexibility, and you can install standard, standard 1, enterprise, standard 2. So, we've got lots of additions. So you can run Oracle. Oracle is a great database that works on all the clouds. Now we're going to talk about NoSQL databases next. So if an SQL database is a relational database, a NoSQL, or not only SQL, is a non-relational database. Now, NoSQL databases are really cool. Why are they cool? Generally in a database, you've got a very structured schema. This thing that's related to this thing. With a NoSQL database, it's kind of relaxed, so we can store our data a little better. So we've got much greater functionality, for example. We can store structured data and non-structured data. So we've got a lot more flexibility, but what really, really we have is scalability. And, in here, what we're really dealing with like a key value pair. And what you can see is we've got a key and we've got some IDs over here for the key. And that's really what we're talking about. But it's the flexibility in the schema that makes the NoSQL databases. So they're not going to be bound to that same table and column schema or data structures like you'd have an SQL database. And it's going to work with structured, non-structured data. So it scales so much further than relational databases. Now, AWS has a managed NoSQL database, which we'll talk about, and then I'll tell you what you can do if you want to go to multiple clouds. Because reality is, unfortunately, there's 2 different things. There's 2 different ways to do this. So I'm going to start right now. I'm going to tell you that AWS has a brilliant, custom-developed, absolutely fantastic database called DynamoDB. It is an excellent database. And again, I can't use it for anything, because it's single cloud and it's proprietary. So If I had a customer that said, Mike, I don't care about availability and I'm putting it all in AWS, I'd say, okay, DynamoDB is your solution. But DynamoDB is highly proprietary. It's also excellent, and it's going to be very challenging to use multi-cloud. So for me, when I see these proprietary services, I throw them all in the trash. Not that they're not good, but if everybody wants 2 clouds or 3 clouds, this isn't compatible on 3 clouds. Guess what? It's useless trash to me. So I'm going to warn you that. So when you're dealing with customers, you're probably going to need a different NoSQL database, such as MongoDB or Apache Cassandra, based upon your read-write loads, and you should know how to choose them. But today we're going to talk about DynamoDB. So this is a fully managed database by AWS. It's going to be high availability. It's going to be low latency. And like Aurora, it's serverless, meaning there's nothing for you to manage. So they're managing the servers, the security, all of it. And all the information is stored on SSD storage. They manage all of it, which means you can't tune it. They manage it. So fully managed service always means less secure than you can do on your own, lower performance than you can do on your own, and less control. But fully managed means simple and elegant, so it's up to you. Each use case for managed and not managed there's a benefit. Now we're dealing with DynamoDB. It is a low latency database, and we can get to low millisecond latency. We can get to sub-millisecond latency if we use a caching like a DynamoDB accelerator. Now, DynamoDB is going to encrypt all your data by default, which is excellent, and it can be backed up with little or no effect on database performance. And it can be set up for cross-regional replication. Again, this is an excellent proprietary NoSQL database. It's just a proprietary NoSQL database. And MongoDB or Apache Cassandra work on all clouds. Otherwise, this is the perfect database. Now, it's ideally designed to work with name-value pairs, but it can also work with secondary indexes, which is really where your applications can access and query different patterns. So when we're creating secondary indexes in DynamoDB, they can be global or local. Local secondary indexes will have the same partition key as the base table, and a global index can span across table partitions. And for the most part, there is a limitation on sizing, meaning a key value can't get bigger than 10 gigabytes, but that's still pretty big. And to increase scalability, DynamoDB is eventually consistent, which means that the second you write to something, it may not be instantly available for all readers. It might take a second or two. No. You can configure that to be immediately consistent, but as soon as you do that, your scalability goes down. So which is it? You want more scalability or more consistency faster? And these are your architectural trade-offs for everything. Nothing comes free. So when we're dealing with DynamoDB, we pretty much want to provision the disk performance we need before we need it. So we have to do so. And we want to make sure we've got sufficient capacity for our reads and our writes. Now, we could pick something and add something called auto-scaling, but AWS auto-scaling on the NoSQL database leaves a lot to be desired, meaning you got a lot of write, all exciting, all these great things that happen. We scale up, but auto-scaling on DynamoDB does not scale back down. So you got a period of a lot of busyness, poof, you scaled up, and you're going to be paying for it forever unless you manually scale it back down. So kind of keep that. No, with DynamoDB, there's some new features that enable us to create infrequent access tables, meaning we pay less to store our information there, but then we pay 25% to save or retrieve our data, which is not so great. And DynamoDB is priced in throughput. So you got to think of this. Could you just create a couple virtual machines and install MongoDB and use them in all clouds? Yes, you can. And it's beautiful. Or you could use this. And guess what? You're stuck in proprietary in one cloud, and getting your data in and out of this is going to be a challenge. So whatever you want to do, it's up to you and the business. The business will drive this. So when would you use a DynamoDB? Well, any case where you would use a NoSQL database like MongoDB or Apache Cassandra. So when near unlimited scalability is needed, this is a good thing. When low latency is needed, this is good. When you've got stuff coming from everywhere like IoT devices, use a NoSQL database. You've got a video game company that's storing the state in the game where somebody is, NoSQL database all the way. gameplay or leaderboards, scoreboards. Now we're talking about NoSQL databases. Got a financial institution that's doing 10 million transactions a day? NoSQL database. E-commerce environments, big environments, shopping carts, inventory tracking, all the way on NoSQL databases. So whether you choose to use the Amazon proprietary DynamoDB or the industry standard Apache Cassandra or MongoDB, that is up to you. You're the architect if you're the architect. And if you're the engineer, you can choose whatever you choose to use. Any of them are good, but understand proprietary versus non-proprietary, open source versus proprietary. So let's talk a little bit about data warehousing. Well, what is data warehousing? Data warehousing is a data management system for businesses towards large amounts of intelligence analytics tools. And why businesses do this is they're trying to gather information so they can take the information and make better business decisions. Why are we doing any of this? It's for business decisions purposes. So think about it this way. We've got some object storage. We map and reduce it. We stick it inside of a data warehouse. And then what do? We use a visualization tool, whether it be Amazon QuickSight or Tabulo. We can actually look at the information. And by looking at information and visualize it, we can make better business decisions. So data warehouses are huge and big for that reason. Now, AWS has its own data warehouse called Redshift. Guess what? Redshift is Amazon proprietary. So if you use it, guess what? You're stuck on Amazon. So we've got Amazon Redshift, and it's a data warehouse that helps you get actionable insights from your data, etc., etc., etc. Redshift provides real-time insights into your business. It's petabyte scale database warehousing. And guess what? It's based on PostgreSQL. So think about this. Amazon Redshift, Amazon proprietary, doesn't work on multiple clouds. Or Postgres, AWS, Azure, Google. You choose. Up to you. And there's lots of really good industrial data warehouses that work on all the clouds. But just understand the Amazon proprietary data warehouse is called Amazon Redshift. And again, it is an absolutely great data warehouse. There's nothing wrong with it other than it's proprietary. And proprietary puts organizations in pretty challenging environments. Otherwise, that's it. So let's talk a little bit. We talk about data warehousing. At least Redshift, it's built around something called a cluster. And what happens, you're going to have a primary node, which is called the leader node, and compute nodes, which actually support the leader node. And what happens is all the queries are sent to the leader node. So you've got a big thing and you've got a bunch of helpers. And when we're dealing with this on AWS, we're going to have two options for our data warehouse nodes: dense compute, which is going to be on high-speed SSD disks, and dense storage, which is going to be on dense magnetic disks. So compute's going to give you much better performance, but keep that in the back of your mind. The last thing we'll talk about before we get into database optimizations, and we're going to take a break to answer some questions, is going to be as follows. We'll briefly introduce the concept of a data lake. What is a data lake? And a data lake is really a repository that allows you to store structured data and unstructured data in the same place at any scale. So the reason we're doing this, so we're trying to create an environment where we can put a massive amount of data that doesn't require a lot of structure like a database, so we can find it quickly and easily. Now, a data lake helps store everything. It's adaptable and changeable, and you keep our data in the native format until we need it. So let's look at it. And this is an oversimplification of a data lake. But basically what happens is, let's say we've got 3 databases. A NoSQL database, I'd use MongoDB, but here we've got Amazon DynamoDB. It doesn't matter. Maybe Postgres instead of Redshift. And instead of Amazon RDS, let's say we've got an Oracle relational database. All good. Now, what we need to do is we need to take the information out of this proprietary format that's in a data that's in the database. So typically what happens is you will have a database engineer that will write a Python Spark script that will extract, transform, and map and reduce that information to be stored somewhere else. And then once all that data is harmonized, it's going to get cataloged and it's going to be placed in a data lake. Now that data lake can have the information run through a machine learning image to make better business decisions, algorithms to run better business decisions, or it can be used for lots of different things. But that's really what a data lake is. And a data lake is combining the benefits of the different databases and object storage, which has metadata, which is like a database, all into a single platform to help an organization be able to deal with large amounts of data to make better business decisions. So kind of keep that. And if this test question comes up, let's talk about it. So, for example, let's say we're storing our databases. Where's it going to be stored? Block storage. Why block storage? It's the only equivalent of a hard drive we have in the cloud computing environment. So I think we covered, before we get to database optimizations, we covered a lot of stuff. So let's do this. Let's see who has questions. Can't data be migrated from Amazon or Amazon databases? Absolutely. If you're willing to spend enough time, effort, and money, you can migrate them. Now, how do you synchronize your data in AWS and Azure at the same time if they're different databases? You could spend hundreds of millions of dollars to try and do it, and you'll never work right, or you could just use the same database on both platforms. So one option is basically free and 100% reliable. The other option requires lots of application integration, and it's never going to work properly. So you could. And once you go serverless, it is really hard to get your data out. And it can require millions of dollars of configuration. So all in all, once you go serverless, it changes everything. You're locked into that cloud provider, and it's very hard to get your data out of it. So don't touch it. Don't use a proprietary database. Use MySQL into, Oracle into, Microsoft SQL into, Postgres onto, MongoDB onto, Apache Cassandra onto. Same thing. No challenges getting your data in and out of applications. And you have more control over the application anyway. And you can negotiate your cloud providers against each other for better pricing. And when one cloud provider goes down, guess what? You don't care because you got another cloud provider. So I would only do it that way. Can I explain mapping and reduction? Sure. And now, Sean, you've got to remember, I am not a database architect. But here's the thing. So I know where you're from. I know which 3 languages you speak. So I know you're brilliant British English. I know you probably know some patois, and I know you speak fluent German. So let's say you have some information that you learned in German, because you were in Germany. You had some special things in patois that you learned in Trinidad, and then you learned some special things in English. Now, I'm going to tell you this right now. When I come into the house and I say to my wife, open the lights, I mean turn on the lights. And the reason I say it is in my Greek English, that's what she sees. But if I say that to the normal American, I say open the lights, and they look at me like I got 14 heads. So what mapping and reduction is really taking the information in one proprietary format and making it into a more uniform format so that everybody can see the same thing. So as a cloud architect, realistically speaking, what ultimately happens is as follows. The engineers speak one language, the business executives that tell us the requirements speak another, and we have to translate between them. So if we bring the engineer to the CEO, which I've tried to do in the past, you get fired because the engineer talks about speeds and feeds, and that doesn't work. So I brought an engineer to a meeting with the CEO many years ago. As soon as the CEO's eyes started to glaze over, I escorted the engineer out of the room. I asked him to get me some things, and I closed the deal. But realistically speaking, what I was there to do was he knew everything. And I was trying to translate what was in that person's big giant brain to the executive, but it was there. So it's really the mapping and reduction function. So mapping and reduction is taking something from one thing and making it uniform so everybody can use it. It would almost be this. If we all decided tomorrow that English was the world's language, And I translated from Greek to English, and you translated from German to English, and the folks in Amsterdam translated from Dutch to English, and we all spoke the language English, we'd all be mapping and reducing to English. Sujit, great question. So, Sujit, let's say you speak Hindi, and let's say I'm speaking Greek, because these two databases are different. How do you synchronize your Hindi and your Greek? And even when we translate, some things don't translate properly, and that's why you can't use proprietary and proprietary, because what you have to do, you can't synchronize them. So in order to synchronize them, you're going to have to spend millions of dollars on constant application integration and constant tuning, and it's still not going to work right. So how would you deal with this every day? Let's say you had two cars that looked identical, and you got in one car, and if you pushed the accelerator on this car, the car speeded up. But if you pushed the accelerator on the other car, it went backwards. That's what happens when we're dealing with multiple technologies and trying to integrate them. It almost never works properly. So if you use a proprietary thing on AWS and a proprietary thing on Azure, they won't be talking to each other. And if they can't synchronize your data, you're going to have all kinds of business problems. So pretty much all that proprietary stuff, you can't do in multi-cloud, which is half of the services that are on the certification exam. Hence the difference between being certified and being hired. What is the difference between a data lake and a data warehouse? A data warehouse is an environment where you store a vast amount of information in a database. A data lake is when you take information out of that data warehouse and information out of the NoSQL database and information out of your SQL relational databases and information out of your object storage. We map it, we reduce it, we catalog, and then give access to it. So a data lake is the conglomeration of everything. The warehouse is just one of the types of databases. Where is the data lake existing? So Brian McCullough, if in your data center that's attached to your building, you have object storage and you have a relational database, a NoSQL database, and a data warehouse, that data lake is going to exist in your data center. If you go to Azure and you create the same environment, it'll exist in Azure. If you go to Oracle, it'll exist in Oracle. If you create the same thing in Google, it will be identical. So it's just the same thing. It's not anything. As long as you use industrial tools to make this and you don't use tools like Elastic MapReduce and you use a Python Spark script like everybody else does, it'll be the same thing in every single data environment you want. Cloud, data center, hybrid clouds, public clouds, all the clouds will all be the same. Vikas, well, could you please explain the database migration process to AWS from AnyDB? Yeah. Here's the simplest solution. You got your database working in a VMware ESXi virtual machine, copy that virtual machine, move it over the cloud, launch it, and now you're up. There is no migration at all. You're running the same database, and it's identical and identical performance, and zero changes need to be made. And Vikas, this is what I would recommend to most people. Stay with the same database they're using in the data center that worked, migrate it over in a virtual machine, and be done with it. Copy that virtual machine to AWS, copy it to Azure, copy it to Google, and you've got a 3-cloud solution. So that's what I would do. Now, if you wanted to use one of these proprietary databases, AWS has a database migration tool, which will pull the information out of your database and put it there. And you can use it, and it's great. Works perfectly. But here's the thing. If you already got a database in your data center in a virtual machine, just copy it to the cloud, and it's up and running, and it requires no tuning maintenance at all. It's perfect. It's identical to what you've been using for years. What's the difference between dense compute and dense storage? SSD drive versus magnetic drive. So dense compute is going to give you much better access to disk, performance-wise. Chris, you can go to the next one. Is Amazon Aurora based on open source? It's highly customized by Amazon over the original sources, so it's 100% proprietary. AJ, what is the benefit of going serverless? Well, you go serverless, you spend an incredible amount of money to reconfigure your applications. And if the cloud provider raises your rate, you can't leave the cloud provider because you're not serverless. So serverless locks you into a vendor solution, makes it really hard to go to multi-clouds. It puts you in an environment where you can't manage anything and you lose all control. So less security, less performance, less control. On the flip side of that, AJ, because somebody's managing it for you, it's simpler and you can focus on code, creating code versus managing an infrastructure. Serverless lets you locked into a vendor. Serverless typically takes a lot of money to reconfigure applications. And if the cloud provider raises your rates, it makes it impossible to leave. So serverless is kind of ugly. So the benefit of going serverless is it reduces the complexity. It raises the management because it's all done for you by somebody else. But here's the thing. When somebody else manages your security, they will never manage it as tight as you could if you wanted. When somebody else manages your storage, it's never as tightly controlled as you wanted. So going serverless means it's easier, but you lose flexibility, security, and control. So it's up to you what you choose to use. Can you migrate object storage database? Well, there's no such thing. As object storage is like a database, but no, you can't migrate that to MongoDB because you're trying to migrate storage to a database. Now you can migrate a database to a database. Yeah, Kyle. So there's a country called Cyprus that's 50% Greeks and 50% Turks. And when Greek people go to Cyprus, they can't really understand the Cypriot Greeks. And here's the reason why. They started out with Greek and they mixed it with Turkish. So you take something open source, you make it proprietary, it's now proprietary. So no, it won't be straightforward getting anything out of it. So that is the data lakes give the business map out business decision? Well, I'll give you an example. So here, let's say you're a cloud architect today, and now you know all the technology that exists everywhere in the world. Can you design an architecture with that? Not at all. You know the technology. If you don't know business and you don't know how to understand business and you don't know how to read a financial statement and ask the CEO about their business, find out their business goals, you can't design the architecture because you don't know what they need. So creating a data lake is great. Here's a big repository of data. Okay, so what? So he needs somebody that can take that data, analyze that data, then figure out what the data means and then talks to the person. That is the valuable person. Just knowing how to create a data lake, who cares? What's the point? And that's the thing I'm trying to get across. There's no point of any of this technology if we can't use it for something. Nobody buys tech because they think it's cool and exciting, ever. So, they buy tech to solve a problem. So what can you do with that information? Well, as it stands out, nothing. When you bring in a data scientist or a business analyst or someone that can go through that data and knows what that data means, they can analyze what to do with that data. They can make recommendations to the CEO, lower your price, raise your price, improve a new website, create a collaboration thing, modify or tweak your supply chain. We know that by mining the data. We collect all this data, we turn it into information to make decisions. So it's never the tech. The tech doesn't do it. We do it. The data lake is a way for us to think about what we can do. How do we mine the data? Does a data scientist set up machine learning? Or do we create an Excel spreadsheet? I don't know. I don't even care. But the point is, what do we use that data for? That's the goal, not just the collection of the data. Chris, you can go to the next one. AI Cloud Arc, as a cloud architect, what are your business requirements? So, can you solve it with MySQL, which is free? If so, use it. Do you need enterprise features and functionality? Oracle sounds great. Is Postgres a beautiful database for you and your needs? If so, just use it. It's free. How about MariaDB? Again, it goes back to the same thing. What is your business requirements? And that will determine what database you should use. And it's never cut and dry. That's why, and then we'll get back to this, that's why the main skill for the cloud architect is actually communication skills, because you're going to be working real hard to get access to this information. So there's that. Now let's talk about some database optimizations. And some of this stuff that AWS on their databases does is cool, really cool if you're using their managed database services. So let's think about this. Let's talk about backup, automated backups, snapshots, and encryption. So when we're dealing with this, we're going to talk about scalability. And under the scalability discussion, we'll talk about read replicas, caching, queuing, high availability, and multi-AZ. So these are the things we're going to talk about. Let's first begin with backups. Any system that matters, you should have a backup of it for when it fails. So keep that in the back of your mind. Now, if you're using any one of these AWS managed databases, the backup are performed automatically for you by AWS. So this is kind of cool. And it doesn't just back up your data. It backups the entire virtual machine. So if your database goes down, you just relaunch the virtual machine and guess what's going to happen? You're going to come up with an identical server, albeit with a new IP address and DNS name, but it's going to be identical and it's going to be super, super cool. So kind of keep that in the back of your mind. So when this sets up, these databases are backed up to object storage or S3, and the backups, or you can retain the backup from 1 to 35 days. So really cool stuff. And a backup will happen during a defined window every day. But here's the thing to remember. When the database is being backed up, right, half a second, 1 second, 2 seconds, the database may not be usable. So it may become temporarily unavailable, or the performance will be extremely degraded. Keep that in the back of your mind. So what does a backup look like? It becomes an image. So when I talked about creating a VMware ESXi image, it's an image that includes everything. When we back up an AWS database, it creates an image, the full thing, which means it's a point-in-time copy of your whole volume, your whole EBS volume. And those snapshots are going to be made to meet them. So here's where it gets really cool. You basically have an image that's a snapshot. You then want to launch it. Here's what you do. You launch the image, and it's going to open up a brand new, identical in every way new database, except for the IP address, because that'll be unique. And if it's got a new IP address, guess what? It's also going to have a new DNS name. And if it has a new DNS name, anything that points to it via DNS, you'll have to change it. But otherwise, all is the same. So we kind of like that, and we're kind of excited by that. So let's discuss encryption briefly. So Amazon supports a couple kinds of encryption. So we can encrypt the hard drive where the database is stored, that EBS volume. We encrypt it by enabling the AWS Key Management Service. So if we now encrypt the entire hard drive, guess what? All our database is encrypted. Now, AWS also supports transparent data encryption, which is used by Oracle and Microsoft SQL Server databases. And again, these are your paid databases, so they've got better functionality. And we can use transparent data encryption with Cloud Hardware Security Module as well as AWS. Basically, transparent data encryption is a form of encryption that encrypts data and decrypts it on demand. So when the data is written to storage, it's encrypted. And when you pull it from storage, it's decrypted. So we kind of love this transparent data encryption. And that's one of the reasons we love the Oracle and the Microsoft SQL Server databases so much. But we prefer the Oracle whenever. But again, it's based upon your workloads. What are you trying to achieve? AWS also allows something called encryption in transit, which means we can encrypt our data to and from AWS database. Now, of course, if we're coming for our data center, we can encrypt it with IPsec or anything we want. So we've got lots and lots and lots of opportunity. But the way we encrypt data along the way is effectively, there's a certificate, an SSL certificate that's created between the endpoints, and we use the TLS protocol to encrypt and decrypt in between things. Now, databases are mission critical devices. And as such, we need them to scale. We need them to scale. So there's two ways we can scale. We can scale up and we can scale out. So let's talk about scaling up. I love scaling up, but the problem is it doesn't work forever. So scaling up is as follows. Our database is now on a 32-core database, 32-core server with a terabyte of RAM. We say it's not enough. So we get one of my big bad servers, 256 cores, 6 terabytes of RAM, and that's our new database. Great, right? Right? Well, it is until the server fails and we're stuck. So keep that. But what happens when that 256 core server with 6 terabytes of RAM isn't enough? For the kind of clients I work with, I might need 50 of them. I mean, I'm exaggerating, but the point is it's not enough. So the next option is scaling out, which is adding more servers. So at some point, you just can't scale up anymore. You got to scale out. So add more servers and capacity. Now, when you're dealing with no SQL databases, this process is easy. For example, with Apache Cassandra, you just add servers. No big deal. With the proprietary AWS, we can partition the database. We can partition any of these databases. Actually, partitioning is going to chop the database into little pieces, and then the application will use the intelligence to route it to the correct environment, which is going to give us much more efficiency. Now let's talk about scaling out. Now, when we're dealing with relational databases, we can't do what we normally do. So traditionally, let's say you've got a load balancer in front of 5 web servers. Web server 1 does its job, web server 2 does its job, web server 3 does its job, web server 4 does its job, and web server 5 does its job. So, there's that, right? But you can't do that. You can't use a load balancer and a database. So with databases, we have to break our traffic into read load versus write load. So here's write load. Orders are coming in from the www.GoCloudCareers website. Somebody wants to become a cloud architect, they sign up. They hit our web server, it hits our application server, and it goes straight into our database. Now, I'm going to tell you right now, that's the way it works. Now, if I needed to scale, I can't create more write capacity, so I've got to do something different. So I got to offload the read. So right now, I'm here. I'm talking to you about AWS stuff. And lots of you folks are asking questions right now, and I love that. And behind the scenes answering the questions, I see a blue wrench with Leo Paredes, I see an Abigail Marks, I see a Chow Pham, and a Chris Johnson, all with this blue wrench, right? So I'm talking and they're answering your questions while we speak. And while they're answering your questions, I'm free to teach. So with the relational databases, we have the concept of read replicas. And what this does is we create read-only copies of our database. And the read-only copies of the database ask people, answer people, while the database is busy. So now, let's say I have 4 read replicas. Chris Johnson is a read replica. Leo Paredes is a read replica. Abigail Marks is a read replica, and Chow T. Pham is a read replica. They all have access to my information. You ask a question, and one of them all responds to you. Now, an order comes in, I'm busy, relaxed, I can write the order to the chart, or something comes in that I need to take care of, I can, because Chow is answering people's questions, and Abigail's answering people's questions, and Leo's answering people's questions. If they weren't there, and I was staring at my chat box, I'd talk for 3 seconds, I'd answer a question. I'd talk for 3 seconds, I'd answer a question. I'd talk for 3 seconds and answer a question, and this wouldn't work. So what is a read replica? It is a read-only copy of the database. And what you do is you separate your read traffic and write traffic. So what happens? You point all read traffic at the read-only read replicas. So you got a question? In between breaks, you're sending your stuff to them, not to me. You're sending it to me, I don't see it. They're dealing with it. And that's great. So they're functioning as read replicas. So read replicas are how you scale relational databases. You take all the read load off of the main database and you send it to the read replicas. So architecturally, what's it going to look like? So here, let's pretend we've got a normal web application. We've got web servers, app servers, and then a database. Now, lots and lots and lots of people, for example, are interested in some of this information. So the web server and the app server write to the main database, and then the read replicas get asked questions. So everybody that has to read data goes here, and all the master database does is write. So when do you use a read replica? Well, if there's a lot of read activity on your network, use a read replica. If everything is just write, read replicas don't help. when you've got a database and people are querying the database or asking you questions and it's slowing it down, get a read replica, take it off of the main database. So if you need extra capacity by offloading reads, set up a read replica. But remember this, read replicas don't boost performance. They're not for disaster recovery. Now, the next thing that we'll talk about is something called caching. Database caching. And caching is a service that's going to take frequently accessed information and put it in memory. And by storing information in memory, the requests don't necessarily have to go to the CPU. So caches work like any other cache. Let's assume I've got 1,000 people asking the same question or the same query in my database. Let's say everybody asked the same question. Does a cloud architect need to code? And the answer is no. But the question is, everybody asks the same question. Does a cloud architect need to code? Now, what is the cache? The first time somebody queries the database and asks that, the read replica will respond and the cache will store it. The next 86 people that ask that question in the next 30 minutes will go to the cache. The cache will say, I got the answer, and answer it. So the cache answers it before it ever hits the read replicas, and the read replicas answer it before it ever hits the main. So that's how we're scaling the database. And caching is just a service to take things out there. So what does it look like? Well, it looks as follows. So if we put a cache here, and let's say we were dealing with www.gocloudcareers.com, and you wanted to pull some information or ask my questions from my database. I'd put a cache in. And then what would happen is the database would respond and all this information would be cached here. So the main database wouldn't be getting asked questions every single time. So the next thing we'll talk about is queuing. And here's where we get ourselves into another predicament in the multi-cloud architecture world. So what is queuing? Queuing is a place to send your data on the way to its destination. So imagine this. I see Abigail Marx's blue thing. So let's say I decide that everybody sends a message to Abigail, and then Abigail says, Mike, are you ready? And I say yes. And then she says, Mike, are you ready for the next message? And I say yes. Mike, are you ready for the next message? And I say yes. That would be a queuing system. So why do you use queuing? When you have contention for resources, you use a queue. So you're going to get on a plane from New York to London. Form a queue. First class goes on. Injured people and handicapped people go next. Then everybody else comes on. Queuing. Why do we do it? Because we can't have everybody trying to get on the plane at the same time. The people will kill each other. So that's why we're talking about these things. So kind of keep that in the back of your mind. What's it look like architecturally? Assuming Abigail's not my queue. I like Abigail being the queue because I trust her. She's really capable. But here's the situation. Here we're sending messages into this queue. This big giant environment. The messages are stored in the queue. And we pull them out when we're ready for them. And that way they don't get lost. What impact does this have on the environment? A whole lot. A whole lot. So that's why we use queuing. Now, queuing is going to smooth it out. Now, this is the AWS proprietary queuing system. So what does that mean? If you're only dealing in a single cloud environment, AWS Simple Queue Service is amazing. Now, if you're dealing with a multi-cloud environment, Amazon SQS is a nightmare because it's proprietary. So we're going to talk about database queuing. If you are on AWS and will be exclusively on AWS and plan on being there forever, Amazon SQS is beautiful. It is an elegant queue. It gives you two options. A standard queue comes in and out as fast as possible, or a FIFO queue, first in and for out. You can use any queuing algorithm, and the queue is great. And I'm going to show you both options. So here's why we use queues. So without a queue, this is what our CPU is going to be like and our disk utilization. We're going to be slow, we're going to peak, we're going to go slow, we're going to peak, and we're going to be all over the place. Now, by comparison, if we can go from the web server to the app server, dump the messages in a message queue of some kind on the way to a database of some kind, instead of having these peaks and valleys, we can just take the messages when we need it and see it's a nice, even flow. So queuing is brilliant. I'm going to tell you this. Every cloud provider has their own proprietary queue like this. Guess what's not proprietary? Apache Cassandra, which can be placed on a virtual machine, can do this in AWS, Azure, Google, and your data center. So for me, when I design an architecture, I don't use Amazon SQS because it's Amazon proprietary. I use Apache Kafka. My teams use that. And that's why we can use it on all clouds at every single time. I don't like being vendor locked in. I am 100% cautious, and my customers, I don't stick them in a single cloud. I give them the ability to be in 2 or 3 clouds when they want it. Now, if I had a customer that said, Mike, I don't care about availability, I just want the cheapest and most innovative thing on a single cloud, I would be using AWS SQS. But my customers demand criticality. If I put all my customers in AWS and they have another power outage like they had, or another impaired network that took the network down, and when I have a hospital and my patients in the hospital, people are going to die. So I can't be dealing with sloppiness in single clouds. I need multi-cloud. I need high availability. So think about this. If you're single cloud, SQS is beautiful. If you're multi-cloud, Apache Kafka may be a better choice. But that'll be up to you and the architects of what you're trying to design for your customer, et cetera, et cetera, et cetera. So I don't use SQS. I don't see a point for using SQS because I'm going to use a vendor interoperable open source platform that I can use on all my clouds. But otherwise, it's an excellent pre-made queue. It really is a great product. It's just, what are you architecting around? So how does queuing help? It reduces contention for resources. That's what we're talking about. It enables you to put your messages in one place, take them out one at a time, at a time, at a time, at a time, and make sure. So it's like Abigail. She says, Mike, you ready for the message? Thanks, Abigail. Mike, you ready? Yeah, thanks, Abigail. Mike, you ready? Thanks, Abigail. I don't lose anything that way. Reliable communication. And that's why we're using queue. So we got a lot of write requests. It smooths out the write load. How about this? I don't know if my server needs 64 cores or 128. Well, I figure it out. Wouldn't it be good if I had an emergency queuing system that I could put my messages in? Yeah, that'd be really nice. That'd be really, really, really nice. And it'd be really, really beautiful. So there's that. So that's one of the things that you can deal with. So that's what we're dealing with. Now, the last thing we'll talk about before we talk about high availability database design, which we'll probably leave for tomorrow because I want to ask some questions, unless you guys want me to do it today, is we'll talk about Amazon Glue. So anytime we're dealing with databases and data lakes, we're always going to be dealing with getting data from one database and putting it into another. And for that, we need some kind of extraction, translation, and loading tool. It's similar in function to mapping and reduction, but it does something different. It's translating English to Greek and Greek to English and Greek to Cypriot Greek, and then Cypriot Greek back to UK English, which is different than Canadian English, which is different than US English. And that's what we're contending with. We're never dealing with the same thing. So that unless we want the same thing, we always have an integration problem. So keep that in the back of your mind. And every database has their strengths and weaknesses. So ETL tools are great. But guess what? Amazon Glue is Amazon branded. And in a multi-cloud, there's other tools that'll work on all the clouds. So, it's up to you. Amazon Glue is an Amazon branded, and it's an excellent, excellent ETL tool. All these Amazon services are great. Don't think they're not. It's just that when you want to go multi-cloud, you need to be more interoperable. And given that 87% of customers are multi-cloud right now, and only 3% they say they don't desire to be multi-cloud in the future, if you want to work in the query, you've got to be able to do multi-cloud. So kind of keep that. So let's talk about that. It's a fully managed serverless tool. Basically, you point the tool to the data and it figures it out, it discovers it, catalogs it, etc. And after it catalogs your data, it's queryable and searchable. So, that's an AWS service. It's a good service. It's a reliable service, but just kind of keep that in the back of your mind. And what's it really look like? Amazon Glue and its crawlers. You basically take Glue and you point it towards your stuff, and it basically theoretically catalogs it, and then you can visualize it with something like Tabula or Tabula or QuickSight to make better business decisions. So, Chris, I think a lot of questions came in because some of that database stuff was ugly and complicated, and I want to make sure we address everybody's questions so everybody has a really great experience. Do you keep every image a backup or is best practice for length of time to hold on to them? Well, that is totally dependent upon the organization's need for the data. So to be fair, I am an architect. I design the thing. I am not a maintenance person or a sysop person. So I don't determine how long we hold on to anything because I'm not in the maintenance people and they generally turn that. But I will say one thing. All organizations should have current images of every production server they have in running. And they should keep images of every important legacy server that they're not using anymore in case they need to rebuild them. And quite frankly, I would keep, if it was my system, I can tell you personally, I have images of every server that I have and that every server that I've ever needed in the past, and I store them all in my storage area network. Because personally, for me, having able to go back to systems that worked is really important. So I always hold on to them, and I hold on to them for years. Well, all servers are going to get an IP address because if not, you won't be able to communicate them. So I'm not completely sure that I completely understand everything that you're actually asking for. So let me see if I can try and interpret it. Well, anyway, when you restore a database from a backup, it's going to have a new IP address of it. It has to. It will have a new IP address. And it will be given an address, and all addresses are elastic IP address or elastic network interfaces. Does scaling out not provide more processing power? Not really. Because in a database, because your read replicas can't do writing, so it's not like they're doing it, they're just offloading it. So not exactly. The lightning strikers, the read replicas are constantly updated. Every time a change makes, they're updated. So this updates occurs 24 hours a day, 7 days a week. If you've got 5,000 transactions a second, it's going to be updated 5,000 times a second. You got one transaction a minute, it'll be updated once a minute. Yeah, read replicas can do nothing other than answer or respond to queries. No, you can promote them to the main database, but that's something different. But otherwise, they only do read. Robert, I've been in this position. Robert, when you have an employer that says, this is all I want, and just do it. So guess what? I've had multiple employers. Mike, I want you to design the network this way. Mr. CIO, if you do it this way, you're going to run into this problem, this problem, this problem, this problem, this problem. Mike, I need you to do it anyway. Write up the architecture document, letting you know that this problem leaves you susceptible to this, to this, to this, to this, to this, and to this. And I make them sign that they've assumed those risks. And 6 months later, when they're hacked or their systems fall apart, and they will, and they pull me into their office and say, Mike, our systems are down. And I pull out the document and I say, I'm very sorry they were down. If you'll recall, I actually made you sign this because I told you this was going to happen. But don't worry. We can fix it so easily by this, this, and this. Now, unfortunately, because we went with these proprietary solutions, It's going to cost us $20 million to get out of these things, but I can do it and get you to the place where you'll be strong, stable, and positioned for growth in the future. And you're going to deal with a lot of stupid people that are not going to listen to you. And you're going to be doing a lot of fixes. And it's not just poor companies. I've done it for big banks too. Tell them they needed something. They didn't believe me. 6 months later, they had an outage. They called me and Mike, I need it yesterday. And I'd say, sure, I got you covered. How do you improve the queuing system in your on-premise cloud? Chances are it's not your queuing system. So if you're in banking, the question is, do you want to be on the cloud? And the answer is, if I've got a database on-premise and I've got a beautiful Nutanix cloud or an OpenStack cloud, and now I get to use block storage, which is causing my database to perform so pathetically horrible that it's taking me 12 seconds for a write load, I say, bare metal server, get rid of this cloud garbage, stick it in a server with 8 times 8 terabyte NVMe drives, get rid of the cache, because you probably don't need it, and then poof, you'll be right into those drives so much faster than you possibly can imagine. Your 12 seconds will be 1 second. So as you'll notice, recently many websites have moved to the cloud. And you'll notice things that used to be fast are now spinning around for a couple of seconds. So when we're dealing with cloud storage, it gets slow. So that 12 seconds to write to a database is there because of that. So put the queue, maybe a Kafka queue. If you need the queue, build that queue. But build much bigger servers and get those servers on bare metal and get the cloud block storage off of it and put it on bare metal storage, which can perform 15 to 100 times faster. So now what are you dealing with? You're dealing with the right latency. So now you're on block storage. And realistically speaking, on block storage, you're not getting more than 250,000 IOPS for the most part. And instead, you go to an NVMe RAID array that gives you 8 million IOPS. So now you go from 8 million divided by 240,000. So let's do it. Let's do 8 million divided by 240,000, which is about what you're going to get. So basically speaking, if we put it on if we put the data on local and the server instead of the hard drives, we can write that data 33 times faster, Vikas, which means if we take 12 seconds divided by 33, by going back to a traditional non-cloud environment, we can take that 12 seconds and knock it down to 0.36 seconds. So it's now sub-second. And that's what you're trying to do. You're trying to basically figure out what is the right thing. So block storage is not right for this application. Server storage, do that and you won't have any problem. Silly question, is the cache volatile? It sure is. Once you reboot it, all the power goes away. It's in DRAM or in memory, which means fully volatile. Brian McCool, when do you use read replicas versus database caching? Well, here's the thing. Read replicas like Abigail and Leo and Chow and Chris, they're answering everybody's questions. And it's great. Now, if everybody's asking them different questions, Brian, adding caching will make it worse. So if everybody's asking that, no. Let's pretend the next question comes in. Mike, do cloud architects need to code? And cloud architects, we don't code. So if 1,000 people ask that question, Brian, sticking in a cache makes it great because then Abigail and Leo and Chow and Chris won't be answering the questions. So it only helps if the pattern of queries are the same. Now, Brian, if you're getting asked 1 million different questions each time in the queries, the cache will add latency to the problem and make it worse. So read replicas improve your scalability by adding read supply. And that's your first place you're going to go. Now, adding to that, if by comparison, for example, the read replicas are answering the same things, then add a cache layer. And if they're not, don't use a cache. It'll make it worse. Great question there, Brian. What is meant by extraction, translation, and loading tool? Something that takes the information from one database and places it into another. Good question, Melanie. Class, I'm grateful for everything you share for free. You share so much. What's in your course that's not shared here? So class, I'll be very honest. Right now, I'm teaching you how to pass a certification. And I'm giving you 10 times more by saying, don't do this and do this. But what am I not teaching you? I'm not teaching you how to be an architect, which means I didn't teach you here how to interview the CEO. I didn't teach you how to become relevant to a chief information officer, chief technology officer, chief financial officer. I'm not teaching you end-to-end system design, which is actually what cloud architects do. I'm not teaching you the real critical piece, class, which is the network and the data center right now. Because what do we do as cloud architects? We take the stuff from the network and the data center and we move it to the cloud. And in certification, they teach you the name of a service, but they don't teach you the network and the data center. So I need to teach that. I also need to teach how to do ROI modeling so you can convince the customer. I also need to teach executive communication skills. I also need to teach executive management skills. I need to teach you guys how to interview for an architect job, because let me tell you, an architect interview and an engineering interview are completely different. I need to teach you how to negotiate business deals as well as a higher salary. And I need to teach you end-to-end system design. And I also need to teach you heavy-duty networking. And I also need, so that's what I do. So in this, we'll give you a certification, which is good for a cloud admin job, which is basically configuration. But if you want to be a cloud architect, you need real professional development training. And that's what we do. Okay. Well, you know, Charles, I don't believe that Capital One has gone exclusively AWS at all. So I'm sure they've got survivable systems in their data center and other places. So I know these banks. I've worked for these banks. I have never, ever, ever once seen them all go to a cloud. And if they went all exclusively to AWS, somebody else will be purchasing them in a few years after they go bankrupt, after they have an outage. But they're not bringing everything to the cloud, just certain workloads that are most efficient. Bernard asked an excellent question. If you heard me right, 87% of customers are using multi-cloud. Does that mean you get to get certified? No, you don't need to worry about certifications. You need to know the cloud. So Bernard, I'm going to be very clear. Here's the certification. This is AWS S3, and here's how to configure it. Guess what? I'm an architect. I don't configure AWS S3 ever, because I don't configure anything because I'm an architect. No, Bernard, I need you to know the cloud, not a cloud. And we're very specific about that. So here's the thing. Imagine, Bernard, you get into your car. And we have an elastic rotational vector degree changer. And you learn all that and the idiosyncrasies of it. And then you go to Google, and they have a cloud-based angle manipulator. And then you go to Azure, and they have an elliptical vector internal or outer directional changer. Now, Bernard, you're going to kill yourself. You're going to have a headache. You're going to go miserable. This would kill me. I'd wake up and want to die every day if I had to learn that. So you see, Bernard, what I do is I learn what a steering wheel is, and I can try in each car. And Bernard, I teach the cloud, and it's so easy. So, you know, what we do when we teach our students internally is we teach the tech. I'll spend the whole day describing server and server virtualization, and guess what? You now know every virtual machine on every cloud provider and how to migrate it. I then talk to my students, and we go deep into block storage. Guess what? If it's on Azure, Google, Oracle, Dell, Cisco's cloud, the Palo Alto cloud, the Alibaba cloud, it doesn't matter. It's the same tech. So no, you don't need all these certifications. And guess what? Certifications don't mean much. Now, it depends the job you're looking for. If you want to be an engineer, a cloud engineer, a bunch of certifications are great. If you want to be a cloud architect, by comparison, a bunch of certifications aren't bad. Because as an architect, you know, getting a certified solution architect professional and a CCNP looks good. But 8 certifications as a cloud architect means you're not a digital transformation specialist or an architect. It means you're an engineer and you won't be hired. So Bernard, I think the bigger question is, what career would you desire? And that will determine the types and the levels of certifications you should get on your resume. But it's not important to be certified in multiple clouds. It's important to know the cloud. And that way, when you get in your car, if you get into a Mercedes, a BMW, a Toyota, a Honda, a Kia, a Chevy, or a Ford, if you know how to drive, you still know how to drive. And that's what we teach, how to drive. Any more, Chris? Okay, so let me remind you of a few things. If you'd like to do some labs that go along with this, download the free lab course we made for you. The link is in the description below. Now, tomorrow we're going to do our completely free How to Get Your First Cloud Architect Job webinar. And if you want to get a cloud architect job, I implore you to come to this. It's completely free. We will tell you what hiring managers desire, how to leverage your life experience and convince the hiring manager you're capable. We will show you what hiring managers want. We'll tell you what needs to be on your resume. We'll tell you the certifications to get. We will tell you how to bypass HR and get hired when you have no experience, and we'll teach you how to get cloud hired. So please be on it. It's completely free. So the next thing that I'll tell you, for a couple more days until Friday, we're celebrating our anniversary sale. We have 30% off. Please take advantage of it if you're looking to build a cloud architect career. And what else? There's a free book, companion book that comes with this, and I want you to be there. So I want to end on this. I am not a fan of proprietary services because customers demand multi-cloud, but it's not that they're bad services. They're good services. The problem is how do you get people to talk to each other and play nicely in the sandbox? That's what we're working so hard to do, to set our customers up right, to build them the absolute best solution so they can be the most efficient possible. That's how we build our careers. It's not just about the tech. It's about what we can do and how we can deliver the tech to improve the world, to make the world a better place. You master that, you are unstoppable in your career. So I just want you to know that. So it's an honor and a privilege to speak to you guys. I am thrilled and honored to be there. If you can give me one last cloud hired, as well as the location of all the folks that are still here, this would make me so happy. I love knowing where you're all at. I mean, I see people from all parts of the world that I believe, and I absolutely love this. Lawrence, I'm super happy to hear that. If you had a good day today, please hit the like button. If you want some help your friends, please share this video, tell them to like and subscribe to our channel, because we have a lot of free content, and we've got a killer security video coming out this week, which we're going to premiere with you. Chris, what day are we going to do that? We're going to watch it live and answer your question?
Friday morning.
Friday morning. And we're talking about one of the real security engineers there. The kind of security engineer that guys like me that have been working for 25 years go to when we have real deep stuff that needs to be. So I got one of them, a blockchain and a security expert, coming Friday. We had a brilliant discussion for about an hour and a half. We're going to play that discussion live for you, and I'll be answering your questions. It'll be lots of fun. It's coming up Friday. So please subscribe and hit the bell to our channel so you get to know about these things. We may have a surprise, a couple of things coming for you to help you in your careers as well. So see us tomorrow in our webinar. Get cloud hired, everybody. So have a great night. I know we do things a little differently. I know we explain things a little differently because we have a different goal for you all. Anybody can pass the certification exam, but guess what? I want you hired. I want you having great careers, prosper careers, good lives, and I want you all to be happy doing something that you love. So that's why we do this. That's why we're doing it completely free, to try and give you guys as much as we possibly can. So love doing this. Had a great day with you today. Can't wait to see you tomorrow. Get cloud hired. You want to connect with me on LinkedIn or follow me? You typically have some leadership and some technical things every single day. Please follow us. Chris will provide that link as well. And join our community. We've got blogs, all kinds of videos, anything we can do to help you build your best cloud computing career. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers, finishing day 2 of our AWS Certified Solutions Architect Associate course. a complete free AWS full course, part 2. See you tomorrow. It's a wonderful day.